Warm greetings to everyone. I, Srishti Singh, take this opportunity to welcome you all to the next phase of this conference, to the plenary session on UAVs for environment. The benefits that drones offer the fields of environmental monitoring and conservation are being realized by an ever-increasing number of researchers, students, and environmental engineers. Researchers require data collected at appropriate spatial and temporal resolutions to describe various environmental processes. UAVs offer quick, easy, and cost-effective insights on demand. For these reasons, we are witnessing the proliferation of UAV-based remote sensing techniques because they provide new perspectives that would otherwise be difficult to study. Their applications, meanwhile, vary widely, from glacial modeling to coastal erosion tracking, species identification, population assessments, etc. For the session, we have amongst us eminent personalities who are ready to share with us their abundant knowledge and experiences. Here we also have Dr. Saurabh Vijay, Assistant Professor at the Department of Civil Engineering, IIT Roorkee. He holds a PhD degree in remote sensing of glaciers from University of Erlangen, Nuremberg, Germany. He worked as a research associate and principal investigator at Bird Polar and Climate Research Center, USA. Dr. Saurabh has happily agreed to be the moderator of the session. With this, I would like to welcome our first speaker of the session, Mr. Lance R. Brady. Appointed as the National Unmanned Project Office Chief at US Geological Survey, Geosciences and Environmental Change Science Center, Denver, USA in 2020. His team has been leading UAS activities since May 2008. During the past 12 years, significant investments were made to develop and implement the unmanned aerial systems policies, procedures, coordination, testing, and operations for executing applied scientific research and daily operational activities. The USGS has been on the cutting edge of this technology and is widely recognized as the leading expert across the federal civil community. Lance holds aviation ratings with the Federal Aviation Administration. He has been actively involved with the UAS technology since 2004 and brings his years of manned aviation, remote sensing, and photogrammetry to the National Unmanned Project Office. He is an experienced professional with a demonstrated history of working in the field of natural resource management and applied remote sensing technologies that include both manned, unmanned, and satellite-based platforms. I request Mr. Brady to share the gist of years of his experience with our audience. The title of his talk is UAS in the United States Geological Survey. Up to you, sir.
Okay, well, welcome from the United States. It's a bright 3:45 a.m. here where I'm located. So let me go ahead and get my presentation started. Okay, are you seeing my screen?
Yes, sir.
Okay. Like she said, my name is Lance Brady, and I run the Unmanned Aircraft Systems Project Office here with the United States Geological Survey.
I would like to interrupt. So
yes.
Could you please put on the slideshow mode?
Is that better?
Yeah. Yes, better, sir.
Okay.
Thank you.
And so the National Unmanned Aircraft Systems Project Office, and I run all UAS operations in the United States Geological Survey. And so we're going to go through several slides. I have actually way too many slides for the time, so we'll run through this pretty quick. So the United States Geological Survey is the science arm of the Department of Interior. And as you can see by the map, we cover a pretty vast landscape with the federal lands that we manage. The Department of Interior, which the U.S. Geological Survey is within, manages 1/5 of all acres within the United States. And that accounts to about 500 million acres that we have the responsibility to manage. And the U.S. Geological Survey is actually the the science arm of the Department of Interiors, and we support the other 9 sub-bureaus under the Department of Interior. And what we're really focused on here at the U.S. Geological Survey is the smaller unmanned aircraft systems that are kind of in the altitudes up to about 1,200 foot above ground level. But we also explore other technologies with some partner agencies like the National Aeronautical and Space Administration, looking at our Global Hawk, Predator B, and even Scan Eagle type platforms. And then the U.S. Geological Survey also has the responsibility for the Landsat systems as well. So we explore the remote sensing on multiple platforms, including manned aircraft, but really our office does focus on the small unmanned aircraft. And so, as a moderator mentioned, the UAS National Project Office was created in 2008. Our first UAS systems were acquired in 2009, and they were military systems that we were repurposing to see if we could use them for science exploration. And then we began training with the military in 2009 as well. And then our first operational missions occurred in the U.S. national airspace in 2011. And in terms of the policy in the United States, all of our national airspace is governed by the Federal Aviation Administration. And so our big policy comes out of the FAA. And then as we step down into the Department of Interior, we have an office called the Aviation Services, and they are responsible for all aviation related missions, including both manned and unmanned. And they have overall policy that governs all of the sub-bureaus. And then the sub-bureaus themselves, including the U.S. Geological Survey, we have our own policies and procedures in place to deploy unmanned aircraft for a variety of missions. In our current fleet of aircraft that we manage are many DGI products, including the Matrice M600, which is our heavy lift aircraft. We also have a Pulse Vapor, which is another heavy lift aircraft. And then you can see the complement of some of the other aircraft that we operate. And we have operated many others, but this is our current suite of unmanned aircraft. We have a total of about 177 aircraft within the U.S. Geological Survey. And these are just some photos of some of our missions and the actual UAS themselves. And so a little bit about the strategy of our office, and that's really to be cost effective in leading the investigation and potential uses of the technology for our scientific research activities in the U.S. Geological Survey, and also supporting the other sub-bureaus of the Department of Interior. And so we really have some key objectives, and that is: one is UAS operator training. Two is our data processing techniques and best practices. Third is sensor integration and making sure that we test and evaluate those and then also approve them for flight readiness. And then we also conduct proof of concept missions. That's been kind of at the core of our work since the beginning in 2008. And then we do some sensor calibration and data accuracy assessments, and then also data archiving and how we distribute our data out to not only the Department of Interior, but also to the public within the United States. And so a little bit about our operator training is the Federal Aviation Administration has Part 107 certification for remote pilots. And so all of our operators have remote pilot certifications by the Federal Aviation Administration. Once they achieve that Part 107, we allow them to go ahead and procure an aircraft system. And those are standard aircraft throughout the department. So we just can't go out and buy any aircraft. We have to do a full test and evaluation of those aircraft. Then the Department of Interior, we host what we call an A450, and it's a basic small UAS course specifically for the Department of Interior. And so it's usually a week-long, sometime 2-week-long course in basic flight operations on the UAS systems. And then we're required by policy to maintain both currency, which is flights every 90 days, and also proficiency every 2 years, where we have to go back to training and fly with an instructor every 2 years. So this is just kind of a history of our UAS activities within the department. And as you can see, numbers really started tracking in 2010, where most of those flights up until 2016 were all US Geological Survey flights. And then as some of the other sub-bureaus adopted the UAS technology, the flights that we conducted really did ramp up. In 2019, at the very end of 2019, we were grounded from using Chinese aircraft in 2019. And so our flight numbers did drop off quite a bit in 2020. However, with our current change in the president and his administration, we're seeing some relaxing of the grounding rules. And so we're able to fly scientific missions and emergency response missions with UAS. So the 2021 numbers, that projection there is actually pretty low. We're going to probably be up in the 5,000 to maybe 7,000 flights annually for 2021. And so I have a bunch of charts, and I'm not going to spend too much time on them, but within the U.S. Geological Survey, we have currently 122 pilots on the books. Some of them are fairly active, some of them are not. But we have a pretty large pilot database and operators with the USGS. I'm not going to spend too much time on that. So a little bit about our data processing techniques and best practices. We provide also some advanced training in data processing, and also advanced operator courses in how we are implementing UAS. The focus has always been on the remote sensing and photogrammetric applications of UAS. And so we put on at least 3 to 4 advanced photogrammetric courses with the department, and we invite pretty much most agencies to participate in that. Our most recent one, we had 56 participants, all participating in Microsoft Teams environment for the training. And it's been very well received, and it's allowed us to really fine tune the standardization of both software and the processing techniques across the department. And the focus has always been photogrammetry and remote sensing. My background is photogrammetry, and the team members that I work with at the National Unmanned Systems Project Office, also many of them have come through backgrounds in photogrammetry, and then as we step up there is a broader remote sensing backgrounds as well. And so really, I don't like the term structure from motion. That's just an algorithm. It is photogrammetry, and we do both stereo 3D modeling and using stereo viewing software to interact with the data. And so many of the derived data products that we generate, which is probably very similar to what most people are doing. We do point cloud generation for the most part. We do elevation models, feature extractions, all the way up to doing volumetric measurements and basic orthophoto production. So several of the projects here are some past work that we have conducted, including the Kilauea volcano response, Devil's Tower 3D modeling, which that's a pretty large, was one of our first larger projects using pretty small UAS to 3D model the surface, including putting ground control targets, not only on the surface, but also on the actual Devil's Tower itself on top and on the sides. We had to put ground control on. We've flown anywhere from, in the middle of the Pacific at Palmyra Atoll, doing multispectral, all the way up to doing algal blooms in Kansas in the central United States. So a little bit about our sensor integration, testing, and approval. We've tested many cameras and sensors over the years. This is our standard suite of sensors that we have approved within the Department of Interior and USGS as a whole. Anywhere from high definition video, which we actually don't do too much with, but we really do focus on some of the commercial consumer point and shoot cameras. Our favorite is the Ricoh GR2, which is no longer in production, but it's a camera that is very stable. And when we're talking about doing photogrammetric type missions, the key is to really have a very stable camera, and that's about the best camera that we've come across for it's not the highest resolution sensor for sure, but it does have a wonderful camera, and we can refine and get a really high quality camera calibration with that camera. We also have a whole suite of digital SLR cameras, and then a whole suite of sensors to include both thermal, multispectral. Our probably most advanced multispectral right now is the MicaSense 10-band camera, which we're operating. And then we also do have some hyperspectral sensors that we're looking at, which is on another slide. But we've also implemented some Doppler radar technology, and probably the workhorse is our yellow scan VX20 LiDAR sensor that we're utilizing. And so several of the sensors that we're currently testing, we have some gas sensors that we're flying over volcanic emissions, ground penetrating radar. We've had several test flights of the GPR. We're continuing, our LiDAR is actually more operational now and not testing, as we have fully integrated that. We also have flown a phase 1 format, or a medium format metric camera. And then we're in the process of testing a resin-on hyperspectral scanner as well. We've flown a geomagnetometer and also telemetry to pick up tagged wildlife. And so those are the sensors that we're currently in our lab testing. So here's an example of the volcanic gas sensor that we've tested over Kilauea. Here's an example of the GPR sensor that we've flown, and the configuration and the data results coming from that. And this was in collaboration with a commercial provider in the United States, Juniper Unmanned, and also with Mississippi State University, which actually developed the payload. And here it is configured on the Matrice 600. And you can see the antenna array, which is actually not as easy to fly as it looks here. It does like to weather vane into the wind, which makes it a challenge to fly in windy conditions. And here's some of the data results from what the data looks like coming off the GPR. And we're using this to detect stream bottoms over some of our hydrologic areas, whether it be rivers or streams. And the penetration isn't too deep, but it does give you a representation of stream bottoms. And here's our first generation LiDAR, which was the Velodyne Puck system. And you can see it co-mounted with a digital SLR camera in the Matrice 600 in the left part of the screen. And the first flights on testing and evaluation, we did at a National Historic Site called Fort Laramie in central United States in Wyoming, and some of the data results from there. Since the LiDAR systems are so expensive, we don't have too many of them. We just have one of the Velodyne Pucks and one of the VX20. Some of the other bureaus within the Department of Interior, we have flown and conducted missions for them in more of an operational capacity because of the cost of the scanners. And hopefully this animation is showing through the World Wide Web, the internet. But this is just a representation of Fort Laramie with the Velodyne Puck data. And here's our VX20 system, which is based on a Regal Minivox scanning head. This is up in Colorado doing a vegetation project where we're looking and trying to classify the stands of conifer trees for really nailing down our prescribed fire or wildland fire program, and doing some monitoring prior to wildfire to see if we can do any type of mitigation measures to reduce the intensity of wildfires. Here's an example of a green LiDAR. So this is a bathymetry LiDAR that we've tested and evaluated. This was several years ago. We are not as pleased with the green LiDAR at this point, just because of our stream courses that can fly. The penetration of that LiDAR system is not that great. And so we're hoping that the technology comes further where we can start exploring bathymetry LiDAR again. But this testing just had limited utility, but we have conducted several missions with the bathymetry LiDAR. Here is the Resonon hyperspectral unit that I was mentioning. This week, we're actually integrating that and conducting test flights next week with this system on the Metri 600. So we'll get a better feel for how the sensor's doing. We have a hyperspectral lab that's not associated with our office, but it's an adjacent office complex to where we work. And we're working with our hyperspectral imaging lab to run some testing of the Resonon sensor. It's not a sensor that they are that interested in. They really like the high spec systems. However, any of the high spec systems are just right outside of our flight envelope for weight that the Metri 600 can operate. And so we are working with them to evaluate the smaller PICs, the hyperspectral sensor that we do have, excuse me. We did do a high spec demo on a platform that was not ours for testing evaluation, and it came back as definitely a system we'd like to acquire in the future. We just don't have the capacity right now with our current suite of aircraft to fly that sensor. So we're hoping in the next year or so we will be able to procure one of the high spec sensors. This is an example of our geomagnetometer that we operated. This is in a test and evaluation period. However, we are looking at a full implementation of the sensor and have flown many projects with it to deploy to our researchers and scientists across the USGS. And this is an example of the data that comes off of the geomagnetometer. Some of our test flights occurred out in the California desert, looking at well casings, abandoned well casings, where it can really pick up the iron within the casings, and you can see it here. You don't really see that, but you can see, since this is a disturbed area, where there is a difference in in the reflectance subsurface. This is also a system that we've now integrated, and it's a telemetry sensor for picking up the tags that are installed on many different wildlife species. In this case that we tested, it was for Asian carp. And so we had tagged Asian carp in this stream, and we were able to use the sensor mounted on here to actually pick up those tags and be able to identify them. One of our most recent published work has been what's called the QCam. And the QCam is a Doppler radar sensor that we conduct measurements of stream flow. And the stream flow data historically has been conducted manually by either erecting a small crane with a weighted measuring that we lift on the side of a bridge or some kind of overpass over a river, and we can take stream flow measurements. And during high flow events, it's a pretty dangerous activity with using that weighted sensor. And so this was developed to try to do the same stream measurements remotely. So QCam was developed by the U.S. Geological Survey in coordination with researchers in Austria. And we have now fully implemented this sensor array, and as it's a fairly small unit with very low power consumption. And so we could fly it on some of our smaller UASs, but we are pretty pleased with the data results off of the QCam for stream flow measurements. And this is an example of QCam. It uses a target that it's actually referencing, and it's actually is seeing the movement of the stream and is able to calculate velocity. And there's QCam target within the water column. Some other work that we're conducting, and some of our flight crew are out this week conducting this. It's a 3-part project looking at using radar systems and also LiDAR to do calculation of snow water equivalents up in the high mountains here in Colorado. And as you can see, traditionally it was using a GPR towed across the snow surface to actually look at the thickness of the water column, and Dr. John Fulton there on the left digging a snow pit so they can actually extract information on the snow water equivalent and to gauge the avalanche risk. And so this is a GPR system developed by the U.S. Geological Survey and the University of Southern California. It is mounted on an Matrice 600. Here is what we're doing with gas sensing. And so this was a sensor developed in partnership with the Environmental Protection Agency here in the United States. And this system this week as well is flying out on a prescribed fire within the state of Kansas, looking at the smoke plume and detecting the gases that are off-gassing from the actual wildfire or prescribed fire. We hope that this will be implemented on a true wildfire at some point this year or next year. But it is a fairly in-house designed gas sensor, and it is right at our maximum payload capacity. So if it would go any bigger, we would not be able to fly it. So it is fairly heavy system to operate. So we'll step through a couple of our proof of concept missions. I know we don't have too much time left, but here's the 3D model of the Devil's Tower that I mentioned. There's a project in Colorado, basically a surface modeling project where we imaged basically derived digital elevation data. This was a contract that we used where a lake had been drained, and we were able to come in after the lake was drained and imaged it while they did repair work on the dam. I'll pass that one. We also have some biological applications to include mallard duck, white pelicans, and elk surveys, and also the telemetry data that we got from the Asian carp. But we've done a lot of biological type projects with UAS. Here's pelicans out in North Dakota. We also flew Palmyra Atoll, both a wildlife and vegetation survey to include multispectral imaging and classification work. Another project that we're doing for stream flows is called Largescale Particulate Image Velocimetry. This is just taking video imagery and it picks out material and debris that are moving through the water column and is able to calculate velocity and trajectory information, basically using a fairly cheap video camera on a UAS system. We conducted about 3 months of missions at Kilauea in 2018 during an active eruption. And here's some examples of some pictures and imagery from that. We also conducted a 3D model of the crater using a Firefly 6 Pro. And hopefully you can see the video, but this is just a UAS parked over one of the lava flows. But we're also able to use the same velocimetry algorithms that we're using to calculate velocity and trajectory of the lava flow itself. We also conducted a water sampling, direct water sampling, where we mounted a hydro sleeve on the bottom of an M600 to fly down into the crater to sample the water down at the bottom of the crater. You can see there with the M600 up in the air with the hydro sleeve suspended below the aircraft. And then they were able to do on-site water chemistry analysis of the water itself on site. We do both geometric and radiometric calibration. About out of time, but this is just some demonstration work that we've done with both geometric and radiometric calibration of our sensors. Then we have a whole data delivery plan and data management plan. All of our data is housed through the AROS Data Center located in the Dakotas here in the United States. And the data can be accessed through Earth Explorer, where both manned, unmanned, and also satellite-based remote sensing data is distributed. And then you can also go to the AROS Data Center, and our work was highlighted in Earth is Art exhibit. And so we were able to produce some products to display there, and some posters that we've distributed out. It's kind of Earth is Art, which is kind of a fun data product that we've provided. We've also developed in coordination with a vendor to actually 3D print a replica of the geospatial data and the elevation information off of the Devil's Tower, which is kind of a neat application as well. And this is the team here that I have the pleasure of working with. Most of us either come through an aviation or a remote sensing or even a photogrammetric background, and we have a varied staff, and it's a pleasure to speak with you today, and I could probably have time for a question or two.
Yes, thanks, Mr. Lenz. This is Saurav Vijay speaking. I'm an assistant professor at the Department of Civil Engineering. Thank you very much for this interesting talk. Very nice overview. And I would like to thank also, like, you had to wake up at 3:30 a.m. So I'm very, very thankful to you. It's not easy. Yeah, so we have a question from the audience. Have you flown UAS in the tropical regions so far?
Yes, we have. We've flown in the middle of the Pacific Ocean in Palmyra Atoll. We've done quite a bit of work there. We've also conducted some research around our coastal environments, all throughout the United States, from the East Coast down to the Caribbean coast, all the way to California. We are in the process of negotiating a project that's next year in Micronesia, looking at using our LiDAR sensor out there. And so, yes, we have operated in the tropical environment, and then in Hawaii as well. We've spent many months in Hawaii.
So what would you like to say, anything about the accuracies in terms of what are your thoughts on experiences, the accuracies of aerial images that you acquire?
Yeah, so, really it's project driven in what our accuracies are. We're able to achieve some pretty high accuracy standards when we're imaging things that we're establishing ground control targets on, and then having a very good camera calibration. That Ricoh GR has really been our workhorse, and we're able to achieve, definitely sub-centimeter accuracy, and in some cases millimeter and decimeter resolutions on stuff. But the interesting thing is, for all of our high accuracy projects, we really do have to establish good ground control targets. And so many of our operators here have years and years of experience with traditional GPS survey equipment. So we go out and we do a full-blown GPS survey on a lot of our higher accuracy requirement projects.
Okay, great. I mean, the second question we have, is there any limit on number of commands that can be assigned to a UAV during its flight from the user for performing multiple tasks in real time? I mean, this is very, general question. Yeah.
Yeah, so we don't really, other than having our QCam where things are generated pretty rapidly, we go out for a week or, several days of flight activities, and we're just acquiring data and then coming back to the lab to actually process that data. And we could spend months processing data from just one project. And so, you know, the rapid piece of it, we're not very rapid, and we're not very unmanned. I mean, we say unmanned and uncrewed vehicles, but some of these aircraft take more crew to operate than traditional manned aircraft. And so I wouldn't say that, you know, it's a time savings, because it's not. It takes just as much manpower, horsepower, and, you know, computer capacity to get to a data product. And so it is very time consuming to do what we do and the research that we conduct. And so there's nothing that's very rapid with it. I would say that, you know, going into the future, we would like either AI or some other technology where we're actually pre-processing the data on the aircraft and being able to offload that in the future. And so the streamlining of data products would be a little bit easier, but right now it's a pretty laborious task to do what we do.
Okay, I mean, at the last, I would like to ask one short question from my side. Is there a possibility, I mean, for any researchers in the US or outside the United States to use your resources? Because you
absolutely, yes. There at the very bottom is our website. It's uas.usgs.gov, and we do have some published research that is in there. That's it's free. There's also the Earth Explorer, where you can download some data products and actually raw imagery. And in some cases, we have invited some international partners to attend some of our photogrammetry training based with UAS imagery. And we work with researchers across the world collaboratively. We're not really, you know, our group is there to support the researchers. So in and of itself, we don't have the expertise in water and in geologic. We're more remote sensing focused and UAS focused, but we're there to support researchers. And we have a lot of projects that are global in nature. We work quite regularly with some researchers out of Australia in development of the QCam. We tried to get QCam basically developed here in the United States, but trying to get a broader audience out there. So we were actually delivering some of those QCams to some researchers in Australia. And I mentioned Micronesia, working with them and developing some projects. So we do have a global reach, probably not as much as a lot of us would like, but the focus really has been on kind of a broader scale environmental monitoring and climate change monitoring.
Thank you very much.
No problem.
Good to hear that.
Thank you very much for your time.
Trustee.
Thank you, sir, for sharing your rich knowledge with us. Now, I would like to invite our next speaker, Dr. Laszlo Bertalan. He is assistant lecturer at Department of Physical Geography and Geoinformatics, University of Debrecen, Hungary. His research focuses on the investigations of surface development processes and fluvial geomorphology, analysis of the recent channel shifts and lateral bank erosion of the river Sajo, investigations of channel morphology and flow structure, photogrammetry-based surface reconstruction in flume experiments.
Welcome, everyone. Can you hear me? Okay.
He has spent more than 10 months at several European countries where he had the opportunity to work in international working environments, learn from different perspectives, and find solutions for his scientific research questions. I invite you to deliver your talk, sir.
Thank you very much for the kind introduction. Can you hear me?
Yes, sir.
Thank you. And can you see my presentation?
Yes, sir. Presentation is being shared, sir.
Thank you very much. And first of all, it's my pleasure to be here as an invited plenary speaker. And as it has been introduced, I'm mainly working on fluvial geomorphology, but now I would like to present not my own research. I would like to present a group of scientists working with drones in Europe. as part of the so-called harmonious cost action, because I am the science communication manager of this team. And this presentation will be quite similar to the previous presentation from the USGS, from the US side, because this presentation will be also about a group of activities of a group of scientists. And as a title of harmonization of UAS techniques for agricultural and natural ecosystems monitoring is the scope of our so-called action. And what is the cost action? This is a European funding body that funded by the European Union to support European cooperation in science and technology. This is the abbreviation of the so-called cost actions. And this one is more focusing on this UAS methodology. And since this amazing conference is dealing with many, many aspects of UAS, many aspects of drone surveys and stuff like that, we have experienced an extreme extension of using UAS as a tool in earth sciences, in civil engineering, and in this case, in natural sciences. And it can cause some like problems and stuff like that if many of the people use their own methods, use different kind of approaches, different kind of perspectives. And it depending on how much of they can acquire about the necessary requirements and the way of implementing a UAS-based research, we have found that it would be nice to somehow support this thing by harmonize all of these available techniques based on the scientific literature and based on the specific parts of natural and agricultural research. So that was the main idea of implementing this group. And as I am the only one who presenting, but let me share that this is a team. As also the previous speaker introduced a nice team. The harmonious cost action is also a group of scientists from all over Europe. And of course, not everybody is plotted on this slide, but mainly these are the people who have contributed in the last 2 years, because this project has started 2 years ago, and we are almost about at the end. And let me share some insights about that. The main topic of the project is the use of unmanned aerial systems for hydrological monitoring, ecosystem monitoring, agriculture monitoring. Sorry, just only the hydrological monitoring word is here, but many other aspects will be presented soon in the following slides. And what is the scope? As I mentioned, it would be nice to improve the ability to monitor river basin processes, agricultural monitoring, and other case studies and case projects in ecosystem monitoring. And our variable of interest are focusing on also state of vegetation, on soil cover of the different agricultural parcels, of course, stream flow, as I mentioned. Hydrology also has some key focus on the project: flow velocity, water level, and river morphology. And also, as I mentioned, the objective will be to somehow find the best practices. Also, it was great to watch the previous presentation, and it was great to hear that also it has a nice aim in the US colleagues to somehow work on the refinement of these different perspectives. Our objective also to try to define integrated procedures to improve hydraulic monitoring capacity and also ecosystem monitoring capacity from different UAS methodology, and to provide tools and new best practices as descriptions for all over the world scientists, like all of you who are attending this amazing conference now in India, but from virtually from all other countries of the world. So I hope that the things that I will present and that all the things that you can reach out at our website will be find useful, and I'm really interested if many people will be ready to contribute with us, to catch up with us for possible collaborations. Another few words about the cost action. This is the code. As I mentioned, network of scientists currently cooperating within the framework of the cost. And we found this group name as Harmonious, which is the focusing on this harmonization thing, promote monitoring strategies, establish harmonized monitoring practices, transfer most recent advances on UAS methodologies to others within a global network. So this is our main key idea. I have to say it again because it's not just for publishing scientific papers. We would like to make UAS methodology as a widely accepted tool, and we would like to force international scientists to use UAVs well, because as I have briefly went through the schedule of this conference, many methodological and technical sessions are taking place, and there also other people will try to focus on what are the possible affecting factors of, for example, resolution, accuracy, and stuff like that. So this is our main objective on this. And Harmonious team involves scientists from 36 countries. And this is a great thing that not just few people from a selected focus group, and we can invite all the ideas and perspective from other scientists, because you live in a different country, you have different regulations, different agricultural areas, different climate regions. There was a question on tropical implementation of UAS, for example. Everybody has a different perspective, and that's how we would like to mix all of these to take into account many kind of things to be able to provide a more refined guidelines for different kind of things. And this is a structure how we do this, and we have a core managing a team by Professor Salvatore Manfreda from Italy, and we have these working groups. Our activity, as I mentioned, kind of wide perspective, but mainly we are focusing on natural sciences and ecosystem monitoring. The first working group deals with the UAS data processing, how to do the calibration, the sensor calibration, image capture, enhancement of the imagery or the flight campaigns, and their possible effect on the deliverables. So this is a working group activities. We have a working group 2, which focuses on vegetation status. Because UAS is now a nice tool to survey local areas like grasslands and forests and other kind of vegetation categories, and they can provide a much higher resolution data compared to satellite imagery. If we have to focus on a local scale, not in a small local scale, not in national scale, they can be really useful tools, but there are many problems that we have to take care, and this working group focuses on this thing. Soil moisture. In the case of climate change and in the region, in the era of climate change, we have to be careful and to save water as much as we can. And in precision agriculture, we have to be able to provide methodology to measure this as accurate as we can, and even with UAS. And because if we have a satellite-based soil moisture estimation or in situ measurements of soil moisture sensors, this can be expensive, time consuming, or in case of remote sensing, the resolution could be a problem. UAVs can help for local farmers to highlight what are the areas of a given agriculture parcel that is having soil moisture issues. This working group deals with these kind of things. Working group 4 is river monitoring focus, mainly in measurements of river morphology, like bank erosion that I'm in my side, river channel changes, and stream flow. I will present other things similar to the previous speaker, the UAS-based velocimetry algorithms that we would like to also refine and harmonize. And regarding harmonize, of course, the working group 5 has the most difficult task to figure it out based on the working group findings, which are the key elements that we have to promote to science, promote to others all over the world, and then to clarify these and do the harmonization itself and stuff like that. And of course, these working groups interacting together and try to implement some methods from the UAS data processing side and so on. And if you are interested, of course, at the end, you will be able to see our website, because we have many already published action deliverables, like scientific papers, data repository, and guidelines already published. You will be able to reach it one by one and to read more on our activities. And now let me present some examples. I mean, I don't have the time to talk about everything, because this group of scientists has already done many amazing jobs. But let me give some insights. For example, the working group 1, as I mentioned, deals with UAS data processing. And as many of you have already met with UAS data, you can met with these kind of problems like oversaturation, vignetting, chromatic aberration, image distortion due to a not proper orthorectification, due to the bad DSM interpolation and stuff like that. Many other things are existing, and our working group is dealing with to somehow reduce this, to give guidelines how to make the best way of survey in different kind of perspectives in terms of natural ecosystem monitoring. Working group 2 on vegetation status, we would like to work with multispectral data. The resolution can be, the high resolution thing that the UAS is offering can be a great advantage in other case, but if we are not working well with these kind of sensitive data sets, maybe we can get not the best results and not the best definitions on the deliverables. Soil moisture working group, and then the working group 3 is trying to somehow test the applicability of UAS sensors, and even with thermal cameras, because soil surface temperature can have a nice connection and relationship between the soil moisture content. And also, if you would like to combine these things with satellite image data, we can even use UAS to somehow refine the precision and accuracy of the downscaling of remote sensing material based on different kind of machine learning and deep learning algorithms. And this is one thing that also our groups are doing. You will always find a reference that already published in our websites. You will find many detailed articles on that. For example, this map shows some kind of implementation based on the combination of satellite imagery and UAS thermal camera sensors. Working group 4, river monitoring. It's like it shows like a nice summary what we are doing. I mentioned that similarly to the previous speaker from USGS, we also do some image velocimetry to monitor river velocities, because in the age of climate change, we have extreme events, and in many cases it's kind of difficult to do in situ measurements of river gauging. And UAS tools has the amazing advantage that you can fly directly above the river, and if you have the appropriate tools and methods, you will be able to do it properly. But for this, we have to find what are the best way to stabilize our UAVs. If we don't have a great gimbal that can provide stable video frames, then you have to deal with this. How can you deal with the raw data? Some pre-processing optimization of the images. And if you don't have any artificial obstacles on the river surface, what can you trace? In this case, you should use seeding, artificial seeding. You can spread around some material on that, but it doesn't. You have to deal with how to do it properly. This is also a kind of thing. Benchmarking, how accurate are the different methods if you use the same data with different algorithms and stuff like that. For example, if somebody doesn't familiar with this topic, we use UAS videos mainly in grayscale versions. In some cases, some ground control points on the river shores. And based on the trajectories that we can measure based on the flow surface, we can estimate the velocities of the water body. And in this case, I mentioned we also publish scientific articles and do data repository. For example, this already published material was published in Earth System Science Data, and when our colleagues has tested several velocimetry data in European rivers. So you can access this. This is open access article, and you can see the best practices, the benchmarking, optical techniques for data collection methods in different kind of rivers, because all over the world we have different type of river, different type of channels and stuff like that. And what are the different algorithms? In other article, you can find a detailed analysis on the different algorithms. And if you just briefly have a look on these figures, you can have the same data with different errors. So what's the best? What's to apply? You will read many great things about this. Harmonization, also in the topic of best practices, how to improve our DSM accuracy, like typical flight plans, camera angles, nadir or oblique camera views. For different perspective, different kind of aims, you have to find which is the best for you according to the available sensors and stuff like that. Some action deliverables. As I mentioned, we are working on guidelines. So one of the things that we are really proud of that we already published last year, a review article on remote sensing journal about the current practices in UASB's environmental monitoring, which has a great interest already. Many citations already. What's inside? We have discussed many possible aspects that can bias your research on environmental monitoring with UAS. Like depending on the output product, what kind of quality parameters you have, what kind of software is available, experiment design, etc. You will read this article and you can have these kind of interrelationships between these variables, and we hope that these guidelines can help you to find the way in UAS research. And of course, based on the study design, what kind of regulations you have in different kind of countries, even in European Union, even in Asia, we have different kind of approaches, different geometric processing, pre-flight field work, how to deal with GCPs. Have you know, or most of you know what is a GCP, but how can you do it properly? We have some articles published, but there's no big synthesization of this. Advantages, disadvantages of different flying platforms, like the typical rotary wing platforms, the fixed wing or the hybrid, the VTOL platforms. We also discussed this. And we just offered a checklist, because many of you, if you go to the fieldwork, it happens many times. Okay, I forgot something. I forgot to bring the SD card and stuff like that. We forgot safety instructions to check. This is also included in this. And also what kind of metadata you can expect, and which are the most sensitive for this kind of perspective. Oh, let me speed up a little bit. And we proposed UAS environmental mapping workflow. You will be able to check it. I don't want to waste the time now, because it's a workflow figure. It needs time to process it. But I suggest you to read our deliverable. And also, we have already published one top-cited deliverable. Also, when we started our cost action, we also published a review article in remote sensing, which is in the last 36 months. This is the top-cited paper on remote sensing, also published by our harmonious cost action on the use of unmanned aerial systems for environmental monitoring. We also introduced many kind of problems and things that we have to face if we would like to have a harmonized tool of things. One slide that I cannot show now. We are working also in a book will be published by Elsevier next year, hopefully next year, and there will be a big summary of our 3-year activity. And few more things, since my time is running out. Let me tell what are the things we are doing. Not just publishing scientific articles and doing collaboration research. We promote this for you, because you are here, you would like to learn and study. And if you check our YouTube channels, last year when the COVID situation got serious, we introduced online workshops. These are free, you can reach it. Even on vegetation status and soil moisture, you can reach it. We did training schools even in Iceland and last year in Austria, just before the COVID situation, when we have selected students and their attendance was free to learn from us, learn from these scientists to be a nice experts on these topics. We also organized general assemblies where the scientists were able to meet with the public. And just the final remarks, and because I'm running out of my time, UASB remote sensing, it's a nice tool, but we have to be careful with this and describe the best practices. And our cost action, the harmonious cost action, is supporting the definition of standardized protocols, and this is our main goal. And some publications, you will be able to read it later. I don't want to waste your time, but these are the already published things. And stay connected with us. Send us your questions, mainly our main website, but we are on Twitter, Facebook, YouTube, and LinkedIn. You can reach us. Thank you for your attention.
Yeah, thank you very much, Dr. Betalan. It was amazing to see such a large team from various European and non-European nations working on various research themes, using UAS. It's amazing. I would like to ask, since as you mentioned, there are different rules and regulations in different organizations and countries, for instance, if you're working in such a large team, do you also influence the policymakers of each other countries? Do you think that, do you have that power? Or?
We hope, because we have to highlight these issues. And in our articles and our things, we highlight, for example, if we promote a method and for example, if the regulation is so strict, you are not able to apply it. But we would like to show that this is great, you can do it, but please somehow be some kind of flexible to make it possible. So this is our main goal, to promote it, even for scientists, even for stakeholders, even for policymakers, that what are the advantages and how can you deal with UAS, and not just like hobby UAS when you just fly and make videos. If you do research, it can support the the progress and development. And we hope that it can get some effect on the policymakers.
I'm sure. I mean, because it's such a nice platform where you can say, okay, look, we are working with this country, and look, they have
Yeah.
regulations, and it's so easy to acquire data and process. Why not have it here as well? So I mean, like, so you can. I'm sure that you can have this. We have a question from the audience for you. Have you ever applied support vector machine classifiers in one of the applications?
I think, yeah, um, let me think, because I'm working on a working group 4, mainly. I'm just a science communication manager. I don't have all the detailed advances in the groups, but I think in the soil moisture group and the vegetation group, they are combining SVM and random forests and deep learning,
Okay.
I guess. So I suggest to the attendee who asked the question to contact us, even like the working group 3 or working group 2 on vegetation or soil moisture group.
Okay.
And I think they are applying it.
Okay. Yeah, great. So yeah, thank you very much from our side.
Thank you.
Thank you very much.
Very much.
Our next speaker is Dr. Ram Avtar. Dr. Ram Avtar is working as an assistant professor at the Faculty of Environmental Earth Science, Hokkaido University, Japan. He got his PhD in civil engineering from the University of Tokyo, Japan. He has worked at United Nations University, Institute for the Advanced Study of Sustainability as a research fellow for 4 years. He developed methods for forest mapping using multi-sensor remote sensing techniques and scenario analysis for sustainable forest management. He is a recipient of the prestigious Green Talents Award by the Federal Ministry of Education and Research, Germany. Currently, he is working on the synergistic use of remote sensing and unmanned aerial vehicles techniques to monitor the environment more precisely to solve environmental issues from global to local scale. I invite Dr. Ram Avtar to please deliver his talk. The title of his talk is Assessing the Influence of UAV Altitude on Extracted Biophysical Parameters of Young Oil Palm.
You are muted, Dr. Ram. Can you please unmute yourself?
Okay. Thank you very much, Chair, for the introduction. I hope, are you able to see my slides?
Yes, sir.
Okay, cool. So thank you very much. So
Sir, can it be enlarged a bit more?
You mean the slides?
Yes, sir.
This is the
Or it is okay, so you can continue like that also.
then let me share the whole screen. What about now?
It's okay, sir. You may continue.
So thank you very much, Chair. So the notion of this study, we have a big project working on multi-sensor geospatial data for oil palm yield estimation. As we know, like in Southeast Asian countries, especially in Indonesia and Malaysia, there is huge oil palm plantations going on and it's expanding year by year. So somehow we need to find some sustainable way where we can produce enough palm oil that would be sufficient for a society without expanding the land further. So therefore, we are looking into how we can estimate the yield of oil palm plantation using different multi-sensor techniques. So looking into not only just the biophysical parameters that is coming from the multi-sensor remote sensing data, but we are also trying to integrate the soil parameters like adaptive parameters and meteorological parameters like temperature, precipitation, and we are integrating these various parameters to integrate, and finally we can use this model to estimate the oil palm yield. If we are successful in estimating the yield, then we can say, okay, the yield is going to be this, like in the future, next year. Then if it can fulfill the demand, then there is no need of further expansion of oil palm plantation. So that is the overall notion of this study. So today I would like to just share some part of this study that we are working on in Malaysia. So the title of my presentation is Assessing the Influence of UAV Altitude on Extracted Biophysical Parameters of Young Oil Palm and Dried NDVI by Crown Projected Area for monitoring its health status. So basically this talk is covering two issues. Like first we are trying to look into at what altitude of UAV is good for acquiring the UAV data, especially in young oil palm plantation area in Malaysia. And second thing, if we can use that UAV data to extract various biophysical parameters, then how we are going to use that biophysical parameters for assessing the oil palm plantation health, and we can identify what trees are healthy trees, which tree is diseased. So that is the main purpose of this talk. So as we know, there are, when we talk about the precision agriculture, there are various stages to acquire the data about, like using various sensors and platform, and we can integrate these biophysical parameters into a data format, and later on we can apply like machine learning or deep learning tools to find or to make some decisions. So that is the basic flow of this whole precision agriculture, and how this AI, the sensor techniques and UAV works together. And all this integrated information can help us to make a better decision. So therefore, if we talk about the UAV applications, it can be useful for monitoring various biophysical parameters, especially for knowing the information about like the leaf area index, what is the coverage, growth stages, health, height, crown diameter at very fine scale. And we can certainly look into in what area, what is the growth pattern, and all those kind of particular, very precise information we can acquire by using UAV data. And UAV can also provide us non-destructive and cost-effective crop monitoring with high accuracy in precision agriculture. So therefore, nowadays it's in the great demand. And if we talk about, because this conference is also related to UAV for sustainability. So if we are looking into the sustainability or sustainable development goals, then this precision agriculture also plays an important role in sustainable development. Indeed, the technology can contribute to achieving not only one SDG, but it can contribute towards implementation of various or several United Nations Sustainable Development Goals. So in this study is focusing on mainly the goal number 1, no poverty, 0, goal number 2, 0 hunger, and 8, 9, 12, and 15. So what we have seen in Borneo, there is huge oil palm plantation is going on, and we are looking into how the science and technology can contribute towards managing the oil palm plantation sustainably, so it can fulfill the global demand without further extension of plantation area. So here you can clearly see the oil palm is the important source of global edible oil, and the production of the palm oil is second largest in Malaysia, and it has the long productivity, and the lifespan is about more than 25 years. So it can sustainably produce the oil palm oil for the more than 25 years. And there is an increase in the trend of the tree health when we talk about the planting health, because now we are going through the climate change. So there are some biotic and abiotic factors, like the biotic factors like that causes some kind of diseases, pests, and pollinators, and some abiotic factors like the rainfall, temperature. So these biotic and abiotic factors can affect the plant health. Therefore, we need to monitor the plant very closely and very precisely. So therefore, of course, the satellite can cover a huge area and provide us various biophysical parameters, but we are looking more precisely, then there is a need to acquire the data using UAV. So if we have the UAV precise data that can help us in detection of the diseases at early stage, because if we can figure out what is happening with the plant growth at early stage, then we can assist, or we can take some immediate or appropriate action that can control that, or that can control the growth, as well as that can also help us to remove the pest or disease from the plant. And that will help us finally to prolong the life of oil palm, and it will increase the productivity of oil palm. So therefore, studying the phenological changes in plant or the biophysical parameters is needed, and therefore we are looking into how we can use UAV data for estimating the the oil palm plantation height, crown diameter, size, and various indexes. And therefore it is necessary to understand the influence of what is the influence of fly altitude, because sometimes people think if we fly the UAV at low altitude, then we can get much better resolution data, and we can get more precise information about some particular features. But somehow it's not clear what was the optimal height for extracting various biophysical parameters. So we conducted an experiment in Malaysia where we looked into what is the optimal height for extracting biophysical parameters. So as we know, in case of oil palm plantation, there is this crown projected area play a major role. The crown of the oil palm increases with the age, and after an age of more than 12 years, it saturates. So therefore, the monitoring of crown projected area can provide us some information about age as well. So therefore, these biophysical parameters are really important and play a major role to estimate not only yield but estimating the health and what is the plant growth and other various biophysical parameters. So here are some field photographs that we captured during the data collection, and we also measured the ground waste height as well as the crown diameter of each and every tree. So here we noticed in the study area there were some healthy trees. Like here you can see this figure A. Picture A clearly shows the healthy tree, but other trees like the C and D, you can clearly see there are some diseases. So because of some disease, the first and foremost effect is near the bunch of these petioles of the oil palm that causes like the stunted growth in the oil palm tree. So therefore, if we can detect all these disease tree or damaged tree at the earliest stage, then we can control that particular pest. So the main pest in this study area was rhinoceros beetle that bore this stem of the leaf. So therefore, we need to identify those diseased plant, and if we can identify those plant, and then it can also help us to control the further spread of this rhinoceros beetles in that plantation area. So the study area is located in the Lahadatu in Sawa. This is controlled by Ladang Sawa Oil Palm Estate, and this total area is about 5.8 acre, and that we conducted a survey, and there were about 275 young oil palm trees about the age of 3 years. So these are some field photographs. So we mainly use the DJI Phantom 4, and we use the MegaSense Red Edge multispectral sensor and Garmin GPS, GoPro Action, as well as Leica GS20 real-time differential GPS system. We had conducted this survey in 2018. And then further we processed the data using this surface from ocean SFM model. So we extracted using the points cloud, we extracted the DSM and DTM, and further we can calculate. If we just subtract the DSM and DTM, we can extract the canopy height model, the CHM. If we have the CHM, then we can estimate the height of the tree or oil palm trees. And we also extracted the crown projected area, because this area provides information about the healthiness as well as the shape, because the shape of the plant play a major role to identify whether the plant is diseased or healthy. So we also try to extract this crown projected area or CPA of each individual trees as well as the height. And so we had measured all, so this is the flow workflow or the flow chart of the methodology that we adopted. So we first basically fly the UAV with multispectral Megasense multispectral camera at different altitude like 20 meter, 60 meter, and 80 meter, and we process the data using the structure from motion. We extracted the point cloud, DSM, orthomosaic. Based on the orthomosaic, we calculated the NDVI and the RE, and from the DSM and DTM, we extracted the CHM, and we also have the ground-based measurement of the height and ground projected area. And later on, we compared and we figured out at what altitude we can get better biophysical parameters of oil palm in that particular study area. So this is the first flow chart, and second one we also looked into we can extract the health of the oil palm plantation area. So basically we calculated the vegetation indexes and the CPA. So based on the value of the, if there is high value of NDVI and high crown project or big crown projected area, then we consider this is the healthy tree. And if there is low value of NDVI as well as the crown projected area is very low, then we consider this is underperforming tree. So based on this methodology, we try to extract the healthy and unhealthy trees in case of oil palm plantation area. So here I'm going to show you some results, the details about the flights. So we conducted 3 flights at 20 meters, 60 meters, and 80 meters. So these are the details. We got many images we processed like using the same system and same software and same machine. So these are the orthomosaic images that we got for the same area at altitude 20 meter, 60 meter, and 80 meter. And further we compared, we extracted the various biophysical parameters. So first one is the ground projected area, and we also measured at the ground the CPA, the ground projected area of all the trees. Then you can clearly see in case of 20 meter, it shows like it has overestimated the ground projected area. So finally, if we look into this graph 10E, then we can clearly see at the altitude at 60 meter, then there is a very high correlation with the ground estimated or ground measured ground projected area with the UAV extracted ground projected area. And in case of as compared to 80 meter or 20 meter. Similarly, we also compared the extracted tree height. We extracted the tree height using the CHM and using the CHM. And we also measured the height of the each and individual tree and the field. And we compared the ground measured tree height with the extracted UAV extracted tree height at 20, 60, and 80 meters. So here also we can see the highest correlation was in the at the altitude of 60 meter. So we can certainly say, like in case of 60 meter, that can give us better information or better correlation with the ground measured tree height as well as the ground projected area. So somehow we figure out like this is the better optimal, like the UAV altitudes at compared to 20 or 80 meter. So here you can clearly see what is the, we also check the what is the accuracy. So it's in case of 60 meter, the highest there was the accuracy about 92% in case of the ground projected area estimation, and in case of height estimation, at the UAV altitude at 60 meters shows 86% accuracy. We later also looked into the NDVI and NDRE. So we realized, like in case of NDVI and NDRE, because we were not able to get any ground-based measurements, so we just simply compared the 60 meter by 80 meter. So we noticed like 60 meter and 80 meter shows better correlation as compared to other flight altitude estimated NDVI or NDRE. So somehow we realized, like in case of low elevation, there was no enough exposure. So somehow like we were not able to get enough better information about the NDVI or NDRE. So here also like 60 meter and 80 meter shows better results as compared to 20 meter. So this is about the biophysical parameters. Later on, we used the, so finally we selected the 60 meter based point clouds, and we try to look into whether we can use that parameters to extract the healthy and unhealthy tree. So these are the points clouds data that we extracted at the altitude of 60 meter. Then here this green color shows the oil palm trees in green, and the ground is shown in the brown and other areas. So here we have estimated the CPA, ground projected area of the individual trees, with the help of the value of the NDVI, and we have made some kind of logic. If the NDVI value is high as well as the CPA, ground projected area, is big, then that is the healthy tree, and if the NDVI value is low and the NDVI value is low and the CPA is also small, that is unhealthy tree. So we looked into the whole area. So there are most of the trees, like about 95% trees like having good growth, and only few trees like were unhealthy trees. So here is the final results. This is the map shows the healthy and unhealthy tree based on the NDVI and ground projected area. So this is the final map. So we provided this information to that particular oil palm plantation company, and they later on worked on this data because early detection of the, as I mentioned, early detection of the rhinoceros beetles can help them to further invasion of this rhinoceros beetles in other trees. So therefore, this information they can use for to removing those rhinoceros beetles in this particular area, or to remove those trees that were infected, and they can, because they were just 3 years old, so they can replant a new tree. So they don't have to like the, so they can control the further infection of this particular disease in that area. So the summary of proposal of this study is UV is quite helpful to estimate or to accurately identify various biophysical parameters, and it provides various methodological approach to extract various biophysical parameters from UV data. And these parameters can be useful indicators to monitor the plant growth and health. And if we have very precise information, that really help us to make a better decision. And our finding is like 60 meter altitude UV data can provide us more accurate results as compared to 20 meter and 80 meter. The highest accuracy to extract the ground projected area and height is shown by the 60 meter altitude, and to produce accurate point clouds capturing the UV aerial images closer to object is not always necessary, because in the beginning we were thinking if we are capturing the data at altitude 20, maybe it will provide us much more better information about biophysical parameters, but it is not true in our case study. And the combination of the biophysical parameters extracted from the UAV SFM techniques useful for monitoring and assessment of the oil palm health, as well as this information can be useful for estimating the age. And if we know the age information, then we can also use it for monitoring or estimating the yield. These are some published paper and acknowledgement. Thank you very much all for coming.
Yeah, okay. Thank you very much, Dr. Ram Avtar. It was very interesting talk. We do have a question from one of the speakers in the session, Dr. Ravi Narayan. He wants to ask you, how to monitor crop health? Is it only based on these indexes like NDVI or NDRE? Because these values may be subjective and we may not understand the health of the agriculture, for instance, because it can be due to some abiotic stresses or something like that. Your thoughts on that?
Yeah, very interesting question. So, because these any kind of disease or especially in the crops can caused by either biotic or abiotic factors. So sometimes it's not easy to clearly by looking into the NDVI or NDRE. We can certainly say, of course, we need to do the ground truthing, and based on the ground data, we can certainly say, because these are the indexes, because all this whole the concept of remote sensing is completely based on the spectral reflectance, and if we are looking into the not only just NDVI, but because this NDRE also shows very significant changes when such certain disease happen in some cropping areas. So like nowadays, not only just NDVI, but there are also other indexes. So therefore, looking into the multispectral images can provide us much more better information, just because previously we were just looking into 4 bands or 5 bands images, but if we can use many bands like 10 bands or 20 bands, like as previous speakers they mentioned, they are using the MegaSense dual sensors that can provide us much more better information, because we can use not only just NDVI or NDRE indexes, but we can also look into the short wave infrared, mid wave infrared, that can also give us some information. So of course, it's quite subjective, but certainly we need to look into the scientific solution by integrating the ground data as well as the UV data or the sensor data.
So Dr. Ravi, do you have any follow-up question that you want to ask?
No, thank you. I think maybe we'll discuss later because of the time constraint. Maybe we'll interact.
Yeah, okay. No problem. So thanks again, Dr. Ram Avtar. And Srasti would like to introduce the other one.
Thank you.
Our next speaker is Dr. Anupam Anand. Dr. Anand is an evaluation officer at the Interdependent Evaluation Office of Global Environment Facility since 2014. Earlier, he was a remote sensing scientist at the Global Land Cover Facility, University of Maryland, where he worked on developing satellite-based global data products and participated in multiple NASA-funded projects, including field campaigns for NASA's future satellite missions. He also worked for the World Bank, working on country risk and vulnerability assessments. He holds a PhD in LIDAR remote sensing from University of Maryland. He has led evaluations on biodiversity, SFM and REDD+, land degradation, fragility and conflict, and illegal wildlife trade. He has qualitative field research experience in South Asia and has worked with indigenous communities in the Indian Trans-Himalayas. Now, Mr. Anand will be sharing his experience through his talk titled Application of UAVs in Environmental Assessment.
Thank you, Srishti. And before I begin, I would also like to thank the organizers, Professor Jan, Vishal, and all those who are working behind the scene for
Thank you so much, sir.
Of this event. And I think Lance, Ram, and Laszlo have really set the stage for my talk today. So I won't be focusing too much on the technology aspect or the science aspect. I would rather focus on the practical application and how it helps the policymakers in making the decision. So with that, okay, just making sure that you can see. Can you see my screen?
Yes, sir.
Okay. So as I said, that I would be focusing on the practical aspect and
Sir, I request you to put your presentation on slideshow mode, sir.
Slides. Okay, there's some. Okay, let's see.
Sir, F5 would do.
Pressing that. Okay, I think there's some issue here. Okay, let me share it again.
Yes, sir. Now it's fine, sir. You may continue.
Oh, you can see my screen. Okay. Is it the first one or the second one? Okay. All right. So do you see my overview slide right now?
Yes, sir. Yes, sir.
Okay, perfect. So I'll just go by that. I have multiple monitors, so I don't know what's happening. Sorry about that. So over the next few minutes, I'll be speaking about the context, and then I will speak about environmental assessment in international organizations. So these are mainly UN organizations and the World Bank, where I work currently. And then how do we use UAVs in the environmental assessment? And this would be followed by short discussion on the challenges and lessons for the future based on my experience in using UAVs in this situation. So in the university, my research was mainly focused on studying the vegetation structure. And for that, the best way is to go and visit all the plots. And the vegetation structure, as you know, has implication for wildlife habitat, for energy balance, for climate change, for hydrology. And that's why we need to study the vegetation structure. And visiting all the plots might not be the most efficient way to do that. So I switched to LiDAR, which was a very promising, and which is a very promising technology for using for studying vegetation structure under canopy. And as you can see here, this is the experimental site where I worked. So this is close to Maryland. It's a part of the Smithsonian Environmental Research Center. And then there are a few sites spread across the world in Costa Rica, in California, in Maine. But the whole idea was to study different kind of forest structure using LiDAR. And LiDAR gives you a really good vertical profile. Just by using LiDAR data, you can count the trees, you can see the population, the canopy density, its structure. So it's very useful tool. But the main challenge with LiDAR is that it's very expensive and more expensive to get repeat coverage. So we're lucky to get few repeat coverage, as you can see in the DSM here, that intact plot, which was disturbed a couple of years later, looks quite different. So you can do volumetric analysis, you can do carbon estimation and things like that. But LiDAR, as I just mentioned, it's very expensive and not available for all the places. Even in United States, which has a pretty good coverage, we do not have wall-to-wall coverage for LiDAR. So around the same time, I was learning to fly the real airplane. So I was flying Cessna, and which also became very expensive. So we started assembling and building the fixed wings, and I joined a club near the university. It's part of the NASA Goddard Space Flight Center, and at that time we were allowed to fly from that small RC aircraft field. Not anymore. So you cannot fly within 30 miles of DC anymore. But those were early days. And at the same time, what happened? So we are using these fixed wings for all kinds of applications. I mean, taking pictures and putting normal cameras, the old cameras, taking the the filters off, the low pass filters off, normal 5 megapixel cameras, and flying and experimenting with that. But at the same time, there was a sudden growth in UAV platforms, so DJIs and 3D robotics. They came up with inbuilt kits, so we didn't need to worry about putting all these kits together. We could focus on the remote sensing, and that led us to few projects first on vegetation structure, of course. So using the data to delineate the trees, but also to get the point cloud and then get the vertical profile from those point cloud and compare it with the LiDAR. So a lot of experimentation with the vegetation structure and with the UAV acquired data. It also led us to a huge project in the eastern part of Africa. It's an agriculture region in Sakkot, where we used the training sample from the UAVs as well as the indices to link the ground-based observation to the satellite-based. So we're essentially using MODIS and Landsat and Sentinel, but the data from UAVs were informing the algorithms and the models and acting as an intermediate between the ground data and the space-bound platforms. So this was about research, and in research, as we all know, we have a lot of flexibility and funding to do these kind of work, which is focused on technology, on science. But once you switch to international development, things are different. There are practical consideration, and this is what happened. So as a scientist, I became a practitioner. I moved to GEF, which is the main financial mechanism for 5 major UN environmental conventions. So GEF supports around 167 countries as of today. And as you can see, all these interventions are linked to the conventions. They are also directly linked with the SDGs. And within SDGs, you'll see that this wedding cake model shows that the environment forms the bedrock for all the SDGs. So environment is very, very important. And my job as an evaluator is to assess these interventions, and these are spread across the globe. So we cannot only rely on one method. We're always looking for new methods, new tools to get evaluative evidence so that we could improve future programming and inform the policymakers to do so. So I will just share a few examples on how I have tried to integrate UAVs into the evaluation work. And some of these work might seem very trivial for this audience, but the link between the data, the evidence, and the policymaker and the policy decision is very, very crucial. And what I want to demonstrate that even simple application can lead you to greater results. So here is an example from the biodiversity thematic area, which is tied to the UN Convention on Biological Diversity. So what you're seeing here is just a sample of protected areas that have been supported by GEF across the last 2 decades. Now we cannot fly everywhere and leave apart flying drones everywhere. So what we do, we use some sampling method and we visit few sites. So one of the sites that we visited is in Colombia. So in Colombia, we did a couple of case studies across the country. And here I would just like to focus on one, and that is on the eastern side of Colombia. This region is known as Choco, and it's one of the most biodiverse regions of the world. At the same time, it's also a region of conflict. So there's a lot of conflict. Even after the peace accord, things are not very normal here. And a lot of illegal mining. And as per one of the estimates, 30% of the funding from illegal mining goes into funding the conflict. And 90% of the mining in this region is illegal. So here is how it looks. I mean, intact landscape, and except for the areas where you have illegal mining going on. And these are mostly around the river. And this river is Atrato River. And actually, while we were there, there was a kidnapping by one of the rebel groups. And we had to follow the security protocol and leave the place in a small aircraft. But that's a story for another day. But the point I'm trying to make is that this is a hard to reach, isolated and unsafe area. So the first, so you can see the only way you can reach the sites is by boat. It takes, on a speedboat, it takes around a day and a half, depending on how fast you're going. And even the ground conditions are not conducive for field work. It's boggy, it's very dense. And as an evaluator, we do not have the leisure of time. So in the university, I have to do similar things in 3 years. In evaluation world, you have to deliver the results in a year. I mean, the time is name of the game, the timeliness. So the first stream of evidence about the illegal mining activity is through an aerial image taken by a drone. So we went to a safe distance and acquired this image. We tried to reach some of the sites so that we could even interview, but at one of the sites, within 5 minutes, we faced hostility, and we had to leave that place. But we went to a safe distance, and this acts as an evidence for the policymakers, for the donors, which are mostly country governments. So this is a very simple way, and a very simple data that we get from the UAV. But we didn't stop here. One of the evaluative question that we ask is about relevance. So are we intervening in the right place? Are we putting our money in the right place? And here it would be the areas undergoing environmental degradation. The second question we ask, is the project design cognizant of the scale of the problem? And here the scale of the problem is the environmental degradation through illegal mining. So do we have any estimate? And unfortunately, we didn't have any estimate because it's a hard classification problem. This region is mostly covered with cloud, and traditionally the way we do classification in these areas is using high resolution images. But here, as you can see, there's a lot of cloud cover. So those high resolution images that are used to collect training data is not very effective. So here we use the UAV data in many places to collect the training data and as well as the validation data so that we could train our algorithm and get a classified map of extent of mining. So here you see how simple application of UAVs were very instrumental in informing the policy decision. So there's a big report that we have to submit to our council, which is the governing body, consists of the representatives from government, so mostly ministers or high-ranking officials who make decisions for future funding. So this informed those decisions. And here's another example where we have been using UAVs in our projects. And this is in other part of the world, Uganda, and this is a protected area. And as part of the support was to enhance the monitoring systems. And therefore, the project used UAVs to count the elephants, so for biological diversity survey. Now, when you look at the numbers between the dotted lines, that which is the period of the project implementation, you see an increase in the number of elephants, and any donor or any agency would be very happy with the results. However, when you look at the numbers, we cannot attribute it only to the UAVs. While discussing this with the biologist, we got to know that this kind of increase might not be ecological or might not make sense ecologically because the rate of reproduction seems a little higher than normal. And we figured here that when we are comparing the earlier survey data, which is based on camera trap or transacts, we cannot just compare without harmonizing the data. But for future, it also tells us that using UAVs would give you a better estimate of the population. So what I'm trying to say here is that we need to be very aware of the context. And as one of the, I think Ram mentioned, that we need to work with the experts, or I think it was Laszlo, that we need to work with experts. And if you're just flying UAVs or you're a remote sensing specialist, you might not have the best understanding of the situation on the ground. So the way we address these kind of scenario is by using a triangulation methods, which is essentially bringing evidence from different streams. So here's an example closer to home. This is another project implemented by UN Development Program, funded by the GEF. And here we use biophysical parameters from the sensors. At the same time, we do beneficiary survey and interviews to figure out the what and how things have changed on the ground. So just to wrap up, here are a few points that I would like to mention on why use UAVs. And this is not an exhaustive list. This is just based on my experience. First of all, it's very efficient. It will save you financial resources, but also human resources. A lot of accidents take place while doing biodiversity survey. Actually, 3 months back in October, we lost a very renowned biologist doing survey on a small aircraft in Zimbabwe. We couldn't even find his body, and 2 other colleagues were injured. And 80% of accidents that happen in surveys happens due to the aviation problems. And particularly if you're working in fragile and conflict area, the risk is much, much higher. So it's quite efficient. The second point I would like to highlight is that it allows analysis at different scales. So we can cover a large area. We can maybe use swarms or multiple flight transects across multiple days. But also it helps link space-borne observation with the ground-based data. Third, it aids in objectivity and transparency. We're always looking for objective evidence. Actually, all the UN conventions are now demanding a transparency framework. The Paris Agreement already has it. The ongoing negotiation for the CBD is discussing embedding the transparency framework already in their work. Also, it's applicable to a variety of assessment methods. So you can use the UAV data to calibrate existing data or to train and validate your models. Also, it helps deal with methodological challenges and can help you with enhanced monitoring, because we cannot visit all the sites, but we can use UAVs in those situations. And one that is not on the list, I would definitely like to mention that, and that is that it helps communicate the results really well. So the aerial images not only act as an evidence, but also as a really good communication tool. A picture is worth 1,000 words, and a video perhaps much more. So it's a very powerful communication tool and a knowledge tool, and easily consumable by a policymaker, because if you start presenting the algorithm and results, they might not be very interested in those kind of technical details. Now, challenges. In terms of challenges, we need technical skills, and we have already seen that it needs a multidisciplinary approach. Just being able to fly UAV or build UAV is not going to help. And most of the assessment teams in international organizations do not have these kind of tools. So we do have a few geeks and nerds here and there, but it's not embedded within the system. And that's why this is a challenge. Also, as an international civil servant, we have to follow the regulations and the operational rules. We cannot, as a graduate student, I would sneak in a drone and ask for forgiveness if it was not allowed. Those were early days, but I cannot do something like that in this situation. Also, UAVs are not the only game in the town. they cannot always answer a question on how and why. And it definitely needs field verification, as the previous panelists have elaborated. So how do we deal with these challenges? And these are based on the lessons I have learned over a period of time. Partnership is the key, and preferably partnering with local institutions, universities, or non-profit organizations who already fly and deploy UAVs on the ground. So that will help you synergize on their expertise, and you don't have to reinvent the wheel in this situation. Also, UAVs are not the silver bullets. So using mixed approaches and methods and tools are the way to go. UAVs would definitely supplement and complement those kind of data and other methods. Also, the cost, the reason I'm talking about cost here is typical environmental assessments do not budget for UAVs or other innovative methods. There's a traditional, I would say, legacy of doing things the way they have been done over a period of time. So these are considered as disruptive technology in international development parlance. So the way we can manage budgets and cost is by taking baby steps, doing a case study here and there, and being innovative about our partnership, about our ways to integrate, and about the business case of using UAVs, because the managers are more receptive to a business case. If you say that it will increase efficiency and save us some money, then probably you'll get a go ahead much easily. And finally, I would say that every other day we have a new platform, we have a new sensor. So we have to approach environmental assessment as a dynamic learning process, because every day the technology would evolve, the tools would evolve, and we have to keep up with the learning curve to be able to do really good quality environmental assessment. So here are some resources authored by me and some of my colleagues within the World Bank Group. So you can learn about operational challenges and how do we deal with that, and what are the guidelines in deploying UAVs in the field situation. And with that, I would like to thank you for your attention.
Yeah, thanks, Dr. Anupam Anand. It was very, very interesting talk. I was amazed to see like how these systems can be used to take evidence in those areas where it's very hard to reach, and it's very risky, and to use those as evidence to the officials working in the government. So it was really interesting example. Do you envision any environmental assessment programs in the Himalayas, for instance? Are you aware of any such programs being done in the Himalayas, or do you think that World Bank Group would do in the future? Because we have forest fires and we have like all these stuffs in the Himalayas. So just your thoughts on it.
I would guess so, because I mean, World Bank Group is very huge. So every day I learn about colleagues using these technology in different parts of the world. And I'm familiar with some projects, not World Bank, but the UN, because we are part of the World Bank Group, but we work with 18 agencies, and most of them are UN agencies. So I know a project implemented by UN agency in Bhutan, where they are using it for early warning system and for identifying gloughs, for identifying the glaciers. And so they fly on regular basis based on the information from the stream flow. So if they get a hint that there's some change, they would deploy a UAV and get some data on glough.
Okay, I mean, great. So I mean, I think the resources what you have shared will be accessed by our audience, and if they have any questions, they will reach out to you. So I would like to thank you again for giving your time, and yeah, thank you very much,
It
Dr.
was a pleasure. It's 8:45 in Washington, D.C.
Our next speaker is Dr. Rabi Narayan Sahu. He is working as a principal scientist with Indian Agricultural Research Institute, Indian Council of Agricultural Research, New Delhi. He has more than 21 years of experience in research, teaching, and capacity building in the field of remote sensing and its applications in agriculture. Dr. Sahu led more than 15 multidisciplinary national and international research projects on remote sensing research programs as PI or co-PI with total funding of 150 crores rupees over the last 21 years. He has been awarded the Young Scientist Award in Agricultural Sciences Section, Indian Science Congress Association 2003, Aryabhatta Samman of Vigyan Bharati 2013, and recently President Appreciation Medal by Indian Society of Remote Sensing in 2018. Currently, he is leading proposed Indian Council of Agricultural Research Network Program on precision farming and cyber agrophysical system for intelligent agriculture. I invite Dr. R.N. Sahu to deliver his talk on UAS for future farms.
Thank you, Sasti. And thank you, Professor Kamal Jain, Dr. Saurabh, and the whole team of USG 2021 for giving this wonderful opportunity to be part of this great event. I think my previous speakers made the things easy for me to take the talk on US for future farming. Many technology has been discussed and deliberated, starting from sensor platforms, calibration, molding, and also different impacts. So I'll be confined more to the agriculture since we are talking of future farm and how UAVs can be useful. And some of the challenges, what we have is, you can see the target what we have by 2050 with the growing populations, and these are the challenges and the kind of production per hectare over the years, what we require is 2.4% per year. That's what the biggest challenge, and you must be knowing doubling farmers' income, so many challenging programs right now on by the government of India. Second part challenge remains is the input applications and their efficiency. And if you look at only rice and wheat crop using 53% total fertilizer use India, and 70% is only for nitrogen. And if you see the nitrogen use efficiency, the how best to nitrogen use whatever you applied, is hardly exceed 30%. I am written 50%, more exaggerated, maybe it is 30%. So that's the biggest challenge again. Same also for the rice, for the irrigation water. So, and water availability per capita will decline 15 to 54% in most river basins by 2025. So these are few challenges I'm just highlighting over here. And second challenge remains is, you see the Indian agriculture is the largest employer with respect to the population involved in agriculture. That's the part of the Indian culture also. So 52% of India's employed population is in agriculture. And it is 14% GDP. Now it's almost 17%, we say, least productive sector, we call it. And most of the culture level is in agriculture, employed 30 to 150 rupees per day. And if you look at the most important but underperforming sector as agriculture, and look at the labor availability over the years, because agriculture has to be so exciting, has to be business to get this young mind into agriculture and make it attractive. For that purpose, the technologies, disruptive approaches are very exciting for these young minds. So what should be the possible strategy for future farm? So strategies may be two approach. One is either you design the plant to be a smart crop. And what do you mean by smart crop is how resilient with respect to the climate change, how best with respect to the input use efficiency. It may be pesticide, maybe water, maybe nutrient. And so how it behaves automatically. That's what the smart crop means by. Means less water, a lot of weather aberrations, still the production is good, production is better. So this is what the smart behavior of the plant with respect to the environment. So how we can do? We can do through modifying the genes of the plant type through the approach called phenomics. The second approach is precision farming. I think my previous speakers, they have been highlighting some of those aspects. So what is precision farming? How best we can increase the efficiency of the input we applied so that we optimize the production system, so that we remain environmental safe, so that we have better cost and benefit ratio. So for that purpose, what we need to do is we need to leave aside the drudgery of the agriculture with respect to the labor, with respect to the effort we put in to make it more automation, put a lot of sensors into it, and since the digital scenario, how data analytics can be used and how the variable rate technology can be used. And left-hand side, this slide shows you how we can actually yield to potential yield, how we can minimize the gaps doing all those approaches. So this is what the challenges what we have. So two approaches I told. One is redesigning the plant type so that you can modify the gene, modify the plant type to behave smartly to optimize the production system. Second is how best we are managing with respect to using variable rate technologies. So for that purpose, so that's what I was talking of plant phenomics, is nothing but the understanding the plant behavior with respect to different stresses, with respect to different attributes, how they behave with respect to water deficit, with respect to nitrogen, less nitrogen or salt or whatever. So how you can do, so you can have a control environment where you can create all those differential treatment and grow the plants. And you can have all kind of sensors, imaging platforms. Because of the time constraint, I can't show you the facility what we have built up in investing very huge amount of money and dedicated to nation by Honorable Prime Minister. So scanning, starting from thermal to hyperspectral imaging, characterizing all the attributes. It's kind of a PET scanning, a CAT scanning you can do of the plant like you do in a hospital. And you can find out those attributes, how they are behaving, how those varieties are behaving in different stress conditions. So same thing you can do also in the field, growing the same plant type and having a framework and where the sensors can move all around, and also having a mobile platform where you can integrate all those sensors down there, or either using a drone or in a low-flying drones, different sensors. So this is what the approach for the plant phenomics, capturing those attributes with respect to stresses. And for your information, till now we have been capturing almost 52 million images generated, almost from 2016. We established this facility. Now 2020, we just finished. So huge database we have generated over the time. Coming back to the precision farming. So it's nothing but managing the variability for optimized production system. And that variability may be because of the crop, maybe because of environment, maybe because of soil. So how do we manage that so that we can optimize the yield? Finally, the yield is the indicator of all those variability. How best we can manage, that decides how potential is your precision farming. And look at the precision farming concept abroad, all like US, Australia, Canada, or any other country. And look at India. There are a lot of challenges. What we have is farm fragmentations, and most of the farming is smallholders, and you don't have a 100-hectare land of a single farm you have. So precision farming approach is going to be altogether different here than what you have outside. So what should be the approach that we'll discuss later? Then what are those variabilities, how you can capture, and how potential with respect to that time scale or spatial scale? If the variability is there, then potential precision farming is there. A single farm unit, a single individual small farm holder, their precision farming cannot be done unless until you take a county or take a village or block, put all those farms together and do in a larger scale. For example, this is studied sometimes back, we did it in IRE farm itself. You see 4.16 hectare only, but you could see so much variability with respect to the soil, inherent variability. So that may be organic carbon, nitrogen, phosphorus, and same also is getting affected, reflected over the yield. So how do we can manage this variability through different platforms, through different sensing technology, and how we can apply? So this is how UAV can be used for that purpose. This is what the main talk today we would like to have. So to capture those variabilities, we have all possible approaches, starting from the ground to the unmanned aerial vehicle to manned aerial vehicle to satellite level. So you have a at the ground, you have some sensors you can do in the calibrated source of light in the lab condition, or you can go to the field and capture the data. And you can put on the unmanned aerial vehicle and capture the data, or you can go to a manned aerial vehicle, for example, AVRIS campaign, which we did very recently in collaboration with ISRO, NASA. Then you can do on the satellites. So how we can upscale from a single pixel to a larger area, and that how we can capture those variabilities, taking advantage of those spectral evolutions over the panchromatic to hyperspectral, kilometer to centimeter, and 7-bit to 16-bit, and in 30-minute interval, you have the data available right now. So keeping that in view, so for example, look at the ground sensors. These are some of the ground sensors which we have been using to address some of the basic questions what we have. For example, you are looking at rhinoceros beetle in palm or coconut, or you are looking at yellow rust, or you are looking at yellow color in the leaf, maybe because of nitrogen deficit or yellow water logging. So how to differentiate that? For that purpose, you need to look at the ground so that you can develop what is that spectral range, which is very sensitive for that purpose. So before going to unmanned aerial vehicle or satellite level or to develop low-cost sensor, these are some of the basic studies which we try to do, starting from 400 to 16,000 nanometer. So using different kind of sensors. This is what the airborne campaign, which we had in collaboration with NASA and ISRO, and it was a very ambitious campaign which has been done, and many sites has been captured. I think many of our participants in which we had, and fortunately we are involved in a number of field site campaign for agriculture purpose. Purpose was how this campaign can be used for the future spectrometer which are going to have on the satellite. Same time also to address some of the basic science questions what we have, how to discriminate the stresses, stress levels, and also go for variable rate applications for agriculture. So both soil and crop health monitoring, how this data can be useful so that similar sensor can be taken on UAV or on the satellite for that purpose. So that's what the main purpose for which we try to do. So as I was saying, starting from the ground to the satellite level, this is a kind of study which was done long back in 2018, one part of the Odisha, where you have a Hyperion data and you have a average NG data. So you have the hyperspectral data and you have also ground spectral data. So try to see how you can go from a single pixel using a spectrometer to an airborne campaign to satellite level, what the kind of accuracy you have. That's what the study tells you about. Then using similar study using airborne campaign, we try to do also digital soil mapping. This is again a recent concept. What the future farm we are going to use is without collecting the soil samples, you have a soil health card program, how all these sensors, all these technologies can be used for digital soil farming. That's what the approach we try to use, soil spectroscopy to use. So this is a part of Karnataka micro water set where this is the soil parameter which has been estimated using average NG data and also multispectral data for environmental covariates and try to develop the model. So this will be very dynamic. You can keep on changing the soil map as it varies. So to some extent, it will complement to the soil health card program of the country. Why I'm saying all these things are whatever the basic strategy we developed, basic research, starting from the ground pixel to using average NG. Same thing we are trying to do on the UAV in the coming years in the precision agriculture program of the country. So coming back to the drones, so these are all possible sensors. I think previous speakers, they have told a about and what are the advantages for that purpose, why drones should be used and how drone is a complementary with respect to the satellite. This bridges the gap in both the satellite and ground remote sensing. So it has its own limitations, pros and cons with respect to drone and also satellite remote sensing. And you look at the 2016 when we had our own drones with a very low cost sensor, an NIR sensor costing 11,000, we tried to fly. And collaboration with the Technological University, Dr. Raghav and his team, we tried to do in IIT Farm Research. So, and the very recent, we starting from a simply single channel NIR, we try to do it hyperspectral using a head-over nano hyperspectral camera and try to fly and get the data analyzed in the field for all the purpose we are looking at. So this is what the technological advancement is taking off, and how from a single NIR channel, when you go to hyperspectral having around 270 channels, the kind of information you have, of course, you are going to answer many science questions. So I should move to next. So coming back to the field phenotyping, precision agriculture you talk about. So these are the IRE, experimental field, where we try to give a differential treatment with respect to water and nitrogen and grow the plant with a different varieties of plants. These are the different germplasms of international rice research institute, and also our own germplasm, 185 varieties, so grown in a field. And you capture the data using, of course, here we have used Mica Sensor Altum, both thermal and multispectral data we try to capture. And you can see the kind of data analysis which has been done, again, using normalized difference rate index. We are able to see the capturing that variability, and each field size is hardly 5 by 5 meter, or maybe 7 by 2 meter. So, but you are able to see that variability. And again, within the field itself, we have around 7 varieties having 3 rows of plants standing over there. And you are able to see that variability with respect to drought, with respect to irrigated plus nitrogen, and also irrigated without nitrogen. And that differential response with respect to treatment, and also from plot to plot, and also from variety to variety, you are able to capture. So this is what the wonderful approach which you are able to get. That's what the high throughput phenotyping you are able to do, not only from the field to field, and also from the plant to plant, how they behave. And almost the pixel size is going to be less than 3 centimeter. So, and within no time, I'm able to, you can see 1 to 190 is the kind of the plant varieties which is grown over there. And these are the differential treatments what we have. And this is what the value, it tells you quickly which plant type, which plant strand was doing good or bad. So you are able to, morning you could fly over there, and evening you are able to generate a map like this to get the differential response of genotype with respect to the differential treatment you have with respect to water and nitrogen. So this is what the capability, you are able to see the differential response with respect to temperature, drought, though there will be irrigated condition, but from one variety to another variety, one plant stand to another plant stand, variation is much. And why that is much? That's what the plant scientists, the genetical engineers, they look at, and they go for the genomics, they look at the QTL mapping, and go for the new variety development, so that wherever you have identified regions, wherever you have that terminal heat stress conditions, there those kind of varieties can be grown. In spite of those climate change scenarios, still you can optimize the yield conditions. So that's the purpose, what we are looking at. Same also with respect to the wheat field, where again, similar studies which was done using a parrot Shikwa. I don't need to go through in detail of same thing, same heat map, same normalized difference water index we try to do. So to do all those things quickly, how we developed our automation pipeline. So that's, we call it drone agri. You can generate all those. And we have all kind of options over there. What kind of sensors you are using, starting from Parrot Shikwa, or Mica Sense, or Mica Sense Altum, or you are using Hyperspectral. Giving that options, and it is auto-guided, and automatically you will generate those maps. And also you can generate this heat map automatically. And you can pinpoint which plant type, which field is really doing good or bad. So this is what the, with respect to phenotyping, same also with the respect to precision farming. I think my previous speaker was talking about LI. This is what the differential treatment of different tillage options and different nitrogen treatment is given in the field. And this is what the image captured by multispectral Mica sets data and different dates. And you are able to see them, and you can see the LI retrieval, both using simply empirical modeling and also ready to transfer modeling. We are able to get LI retrieved automatically. And for your information, LI is one of the important parameters go for the yield estimations. So how best you are able to retrieve this parameter? Once you retrieve this, then so LI is again going to decide how good is your biomass or yield. So based on that, you can go for yield estimations. You can enforce into different crop simulation modeling. you can enforce this drone derived parameters so that you can go for the yield forecasting. So this is what at the different stages, how LI is behaving. So this is what with respect to precision farming. Coming back to the very recent approach, what we had in 2020, 2021, recent, this is what the only a few days back, we have taken this image. So you have a Herval Nano Hyperspectral, where this is one of the smallest camera. I think my first speaker, Professor Brady, was talking from UASGS using high specs camera. And that camera is heavier. So this is why we of those camera, but this camera is hardly 500 grams. Of course, we gimbal, and this is a DJI 600 matrix, which can carry up to 10 kg of payload, or maximum 6 kg. So putting the planning, you to map, you can see the spectral signatures with respect to the control. Control means everything is recommended healthy conditions, and nitrogen stress conditions and water stress conditions. Once single image is captured, all those things has been orthomosaic using different protocols, and it's a huge data. You need really high-end systems to do it and wrap over it. And then you can do either a single individual index calculations, or you can go for multivariate approach or machine learning approach to retrieve different parameters, or you can characterize them how they are behaving differently. For example, we just did it's NDVI, or also we did NDI, and you are able to see the difference, how they are behaving in the field conditions. So again, same thing, when you fly over a field where you have 8 different treatment of nitrogen, and you can see the treatment of nitrogen given 8 treatments, and also 3 irrigation levels, and you can see the kind of spectra which was generated. And again, using multivariate models, MLR, we're able to generate a nitrogen map of the field. So each pixel is able to give you what is the nitrogen content. So you can see, interestingly, is that not from field to field, the nitrogen variations, also within the field there is a variations. So you have a raw image over here, and from the raw image, you got a derived image, nitrogen, that's what the thematic image, which can go onto drone now, go for a liquid nitrogen sprayer. And for example, why I'm saying drone is going to be, again, a part of the future farm. It's not only going to map it, it's going to give the exact location, and also it's going to be a variable rate applicator. So now many of us are very much aware of drone is very much used now during Corona. Before that also, in many places, people have used in the farm field, mostly in the south, for the spraying, for the pesticide spraying. Now also it is going on. So what I mean to say is the variable rate applicator drone can be used. So same time it is a mapper, and this image can get into the chip of your decision maker and can go for a variable rate applicator. So this is what the kind of precision farming or variable rate applications, what you can do. So as I told you, we have huge database what you generate. I think one time fly, we are getting the data in, I think that small field we could see is something around 8 GB data we capture using Herval Nano, 8 to around 10 GB data, only a single image scanning. So that huge data and can be used, and this is what the control conditions we try to do, how quickly you can go for the flowering detections using deep neural network methods. So this is what the standardized method we try to develop. And once it is done, same thing we're trying to implement over the field, how the plant is behaving and finding out number of years in a plant. So accordingly, you can go for the production system estimations. So this is what has been done, again, simply RGB image, counting simply particulate detections so that you can go for the production estimation. So what I mean to say is, whatever the data analytics, big data analytics we have, we're trying to implement there, not only from the control conditions, same thing we're trying to go over the field conditions. So here again, number of leaves, how you can capture. So this is again a technique. Again, one of the students from IIT Bombay is working with us, Professor Adi is his chairman. So again, using CNN, we are trying to able to do that. So what I mean to say is we're trying to use, explore all possible AI approaches, big data analytics, how quickly we can analyze those data and come back to. I think this is going to be almost last image. So this is what 10,000 rice genotypes grown over in a field over here. And you can see how those 10,000, whatever the rice you have in the country, all those rice grown in a place, to see their behavior. And let me, I don't know whether I can play from here. I don't know whether movie can be shared, but sorry for the time. Again, time is running out. I don't want to go through. So quickly, you can just sitting on the lab itself, you can visualize how morphometrically they are different, how colorimetrically the plant types are different, and how they are behaving with respect to the treatment you have given. So this is what a very easy way. This is simply RGB image, which we try to do it. So what I was talking is, this is what the US today, it takes the growing use of drones to transform agriculture. That means a drone is going to be a tractor now, very soon. And that's what in India, today, they say farming to go high tech, drones will monitor crop and soil it in India soon. So this is what optimistic approach we have in country, though we have a number of challenges, though we have been working this community, this platform, UASG 2021 is discussing all those technologies, what we have and what are the challenges, starting from policy issues, from DGCA. And I think we are really moving in the right directions. But some of the silent questions, what I have, because since almost now more than 5 years, I have been working on drone remote sensing. Why at all the farmer should go for the drone remote sensing? If at all he has a high resolution data of 10 meter of Sentinel or any data, or even if Amazon is going to sell you the high resolution RGB data, so why at all he should look for investing money on UAVs? So these are the few questions to be answered. And so for that purpose, so I think, let me read out it. What is the incentive for a farmer to adopt new imaging technology when most farmers in India don't use what's available to them now, and even if many private sectors? So we have huge, I think I am not talking of remote sensing, satellite remote sensing here, because many speakers I could see, they are from ISRO and their authority in the field, they could have spoken. So you can see the galaxy of the satellites what India is having, starting from spectral and radiometric and spatial resolutions. So still it is underutilized. So how do we expect this drone technology is going to address some of these problems, or the farmer will be excited to use it? Of course, there are some solutions for that. How will drones change the equation? Why will farmer or crop consultant invest the money, time, or expertise analyzing UAV-derived data set if they are not doing the same with the manned aircraft or satellite-derived data they can already purchase? Then how will US service providers convince farmers that their data is more valuable, more actionable, and has a high rate of interest when so many farmers seem to be relatively uninterested in data in the first place? So this is a challenge because many startups are part of this conclave. So I think we should discuss, we should come out with something. Simply NDVI image is not going to excite anybody unless until we come out with some kind of application or practical oriented. So are farmers prepared to adjust their field operations personnel to be data driven? How will they make this happen? So let's work on it together to answer this. So with this, I must thanks to the organizer for giving this opportunity to share few of my thoughts. And I must acknowledge my students, research fellows, and also fellow colleagues who are associated with me. Thank you very much.
Yeah, thank you very much, Dr. Ravi Narayan, for a very insightful talk. As we are running out of time, I would like to ask you one question regarding, is that fair to say that drone system or these systems can make a bridge between what we observe from spectroradiometers or such instruments and also satellite remote sensing? Is that fair to say that?
Yes, that's what I told. That's what I wrote. So, I had a slide. I think many of us, we are now educated enough to differentiate what are the challenges we have with respect to satellite remote sensing and what are the advantages we have with respect to drone remote sensing. So pan-India, you can't fly a drone to get a crop estimation. I have a policy document of Niti Aayog where I have the member secretary, I published that, to say how many million images, drones you need to have to go for a crop insurance at a time. So for that purpose, you can't compromise with the satellite data. You have to go for satellite. Of course, wherever you have anomalies, there you have to go and see that you are able to see where the satellite has its limitations with respect to weather or resolutions or not availability or the sensors. There you can use drone to get it. So from a single pixel to a larger area, the area of interest, you can look at the drone remote sensor.
Okay. Yeah, that's great to hear. I mean, your talk will remain on the system, and I hope audience will have questions and will be in touch with you. Thank you very much, Dr. Ravi. Sasti, you can take forward.
Thank you.
Yes, sir. Thank you, sir. Our next speaker is Dr. Brian Mark. He is a professor and state climatologist in the Department of Geography at Ohio State University and also PI at the Bird Polar and Climate Research Center. He has done PhD from Syracuse University, Department of Earth Sciences. He directs the Glacier Environmental Change Research Group, comprising graduate students and staff in internationally collaborative and student-centered research funded by NSF, NASA, National Geographic, Fulbright, the Western National Parks Association, and other sources. His interest is into climate glacier hydrologic dynamics over different timescales, with a particular focus on the coupled human natural systems of water resources of the tropical Andes. The title of his talk is UAV Integration in Mapping Mountain Glacier Change and Hydrologic Transformations.
Thank you very much. Can everybody hear me okay?
Yes, sir.
Okay, good evening. It's been a long day for you, but congratulations on a fantastic conference. I'm learning a lot in the session that I've been able to watch. And I know you've been at it a long time because I watched you kick it off before I went to bed, and then I woke up and you're still going at it. So
yes,
I've yet to have my breakfast. I know we're prolonged, so I'm going to go right to share my screen. Can I do that? And I'll get underway. So, okay, I'll continue. Everybody hear me okay still? Yes? Am I still okay? Everybody
Yes,
yes, sir. Yes, sir.
We hear you.
Okay, because I'm having a bit of a ripple in my internet connection. Okay, so what I want to do today is maybe stay away from too much technical detail and just share you a little bit about what it's like for me as a professor of geography to integrate this fantastic new technology into solving or addressing some of the age-old problems we're facing. And I want to say right off the bat that this is still a work in progress and it's taking time and patience. But I think what I want to emphasize is that collaboration internationally, partnerships, and long-term investment in place and research and in people is where we got to go. So my motivation as an educator is to think about my students as stewards of the environment. And as a geographer, I'm fascinated with connections across scale, in time and space. And so I see these drones, as I've heard all of the previous speakers hail their virtues, as an integrator of scale. We're able to connect and interconnect between satellites and the ground. And so in this regard, I'm going to take you to a couple places and talk about some case studies that we've used drones to look at glacier mass changes and to think about this in terms of, this is a great tool, okay, but it's also a really important context in which we can practice the craft of education and really forward innovatively how to use hands-on learning in problem-solving skills with an interdisciplinary team to get at some interesting answers that we wouldn't have had otherwise. And in this regard, my context and base of operations is the Bird Polar and Climate Research Center at Ohio State University. And we are very purposefully in my group studying the environmental changes below glaciers, around glaciers, areas that don't even have glaciers now, but have in the past, to think about the impacts that people have on this environment and the way that glaciers have imprinted on society. I say student-led because all of my fellow researchers are students, PhD students, master students, undergraduate students, also postdoctoral researchers and research associates. And we work as a team and we collaborate and put forward this idea that there are ways that we go about things that are equally important to the things that we study. So I want to give a quick tribute also to Forrest Chesso. I always mispronounce his name, but he, I think, is gracious enough to forgive me. who's a PhD candidate and has done a lot in forwarding the drone agenda in our group and started a innovative group that we call the Mountain Drone Team.
Excuse me, Brian.
I also wanted to give a hats off. Yes.
Yeah. I mean, your slides are blurred somehow. I don't know, because I checked in the system as well. I mean, it's all blurred. So can you just somehow fix it?
Everything's fine on my screen, so I'm not sure.
Okay, maybe just, yeah, it looks blurred to me. Maybe other speakers is the same with you. Dr. Ravi Narayan, do you see?
It's still blurred.
It is the same. It's blurring. It's not clear.
Yeah, it's blurry. Yeah.
I think bandwidth is an issue at his end or whatever. Maybe since we all have same problem, maybe at his end.
Yeah, because I have checked in different systems, and they all have the same.
It's frustrating.
I mean, I see you I see your entire laptop or computer screen blurred, even the task manager and everything. So it's not just the slides, but the entire system.
But the brand looks good and clear, very bright. His image is very nice. Only the slides.
So does it help if I turn off my camera?
You can try again.
Try.
Okay, let me try that.
Better.
Yes, perfect. It looks much
good.
better. Yes.
All right, good. Well, that's good. So I'll get rid of my beautiful camera picture of me because you don't really need that. What's more important is that you see these wonderful characters. I want to give a special tribute to Dr. Saurabh Vijay, who's invited me to this conference. I'm really pleased to see him situated in India in an academic role because he's a fantastic educator. And what we were able to do in the short time that he was with us at the Bird Polar Climate Research Center was start to practice even more of what I like to call the student-led international collaboratory. And here you can see Saurabh learning how to use a drone from an undergraduate student. And you can see people from Bolivia. You wouldn't know this, but there's Bolivians, there's people from India, there's people from the US in many different states involved in this project. So to take a step back in the bigger picture, why do we care about glaciers in the first place? Well, it's where a lot of Earth's fresh water is extant, and it's changing. And if you look carefully at the distribution, of course, most of Earth's fresh water is locked in ice. The one that's most available to us are those mountain glaciers. And what draws me to think about glaciers is their connection to people. And so what I've done in my research time is really focus on the tropics. If we look at mountain glaciers globally, first of all, I live in a state of the United States called Ohio. And if you look at a map of Ohio and you take the relative area of all the mountain glaciers in the world, you can see that we have about 5 to 6 Ohio's worth of ice cover, most of which is up in the North American, Alaskan coastal ranges. But you can see a large percentage in Central Asia and the Himalayas and the third pole region close to where you all are. But if we draw a histogram of the world's population, and we count it by latitude, the overlap with the tropics is outstanding. 30% of the surface area and a large swath of humanity. And the glacier area, of course, is very small of what's left in the glacier. And I've circled Peru because that's where most of the remaining glaciers are. Now, I've been involved in mapping tropical glaciers in other parts of the world. And we can say this pretty unequivocally that the few tropical remaining glaciers are melting fast. So here's pictures of photos changing in the Kilimanjaro, Africa's highest peak, and representative of the glaciers there, they're disappearing. The maps we've made, if you trace a straight line through them, they'll be gone in a few decades. In Papua, in Indonesia, we've extracted an ice core right to bedrock and inserted a stake all the way to the bedrock and see the surface exposure. So this glacier is disappearing by surface area, but what's really important to note in this is also the total mass. And you capture that well by looking at the vertical deflation of the surface. And so that's what's emerging in this stake. And of course, you can't quite see the surface image deflate, but you can see on the right-hand panel a series of photos how this ice is disconnecting. And what we see when we do this is get radiative feedbacks through the exposed surface that's enhancing the melt. Now, of all the tropical glaciers in the world, most of them are in Peru, in South America, in the Andes. And these glaciers as well are receding. And in fact, the rate of recession is accelerating. So this recent publication that used active sensors has shown that a 3D mass change evaluation using a geodetic method has shown a 30% ice loss just between 2000 and 2016. Well, what's going to happen in the future as this ice is lost is a big question. And how do we grapple not only with the loss of ice and the phase transition of that into water and its impact to water resources, but what about the environment that's also permanently frozen? As it loosens up, there's a number of hazards that grow. So future projections show that in the Andes, we're going to project to lose quite a lot. And this is because there's an enhancement of warming with elevation. So my group has been looking at this from a coupled perspective. We call this a critical convergence because we can't just talk about ice separated from people. And so the way we frame this is to address it from a transdisciplinary research perspective. And we formed a group called TARN. And this is a publication in Spanish because it's really important to publish in a local language, just showing our framing of looking at climate change's impact to glaciers and to hydrologic change. And you can sort of see that nice linear tracking. Water that's melting is flowing downstream. And a tarn, incidentally, is the name of a glacial lake. But of course, there's important feedbacks that go directly to society and society back to influence the accessibility of that water and its quality. So emergent in this environment is a lot of vectors of change and vulnerability. And so what I want to focus on is just the way we've been trying to constrain our understanding of that water mass as it's changing from the glacier and melting, and then going downstream. And in Peru, we have this amazing scenario where water that's leaving glacial storage and not being replaced ultimately is being irrigating the coastal desert, which due to the latitude and geography is very dry, but if you irrigate it, it can be a very abundant agricultural base, most of which is going to export. So this question of what's happening in between those glaciers and the people has been the focus of our study area. And so when I first started work in the area, I was a PhD student in the last century, at the end of the 20th century. And I took a photo of this glacier, which is representative of the modal size of glaciers in the largest concentration of tropical glaciers in Peru, which is the Cordillera Blanca, or White Mountain Range, named for the glacial coverage. And this is a glacier called Llano And here's my good colleague, Jesus Gomez, who at the time was unemployed from his previous work as a research scientist in the government due to neoliberal reforms. In 2015, the glacier obviously had receded a lot, and not only in extent, but in volume. And you can see the surface deflation by looking at those emergent features at the middle of the glacier. A dramatic recession that's evident and something that can be mapped from space. But the question really is, what's the important water resource? And that question remains to be constrained with a volume estimate. So we need a three-dimensional map. And so my early ways to get at this, okay, was to think about constraining where we had three-dimensional geodetic control through aerial photographs and to update that with differential GPS. So taking the aerial photographs for the region that were best resolved from the 1960s, and then going and trumping over these glacial surface areas from representative aspects, I was able to start to question and get at total volume loss, and then think about what's forcing it. What are the climate controls? And to test hypotheses of radiation versus temperature. But of course, you notice when you're doing this on foot as a PhD student, there's a good amount of energy involved, and there's only so much area that even I could cover when I was super fit. Okay, but notice the local conditions of access requiring to adapt to transportation. But not only that, but transport and reliable people to help me get on there and belay me on the ice and to transport and feed me and help to navigate the property. I then proceeded as a group, we invested and got some grants through NASA to fly LiDAR. So using an active laser scanner, we used a Leica instrument, and we were able to cover about 600 square kilometers. Now that was not quite our full target area because there's always complexities when we try to do things. And in our case, we were shut out of actually using our own instruments because of import limitations. And now you can only imagine this is accelerated in the days of travel shutdown. But we were able to collaborate with a local engineering firm, a mapping company that had a great instrument, and we were able to get 75% of our coverage areas, and then start to think about volume loss in specific glaciers as well as their surface area. And we were able to realize that scaling factors that are done empirically across the world don't really estimate very closely the total mass loss. And it's not capturing all these radiative feedbacks that we know are occurring in the surface deflation. And so we could quantify this with a new scaling just by looking at these case studies. This was a work by a PhD student, Kelly He, that 36% more of the volume loss than expected from surface area calculations alone were being lost. And this again comes through that geodetic control. Well, here's the appeal for UAVs. And this is where another PhD student of mine got interested in taking these new technologies, which at the time was about 2011. He wanted to think about how to then map what's going on with the water as it's leaving the glacial terminus and entering what we call the forefield of the glaciers in the proglacial valleys. And so his idea was to use UAVs. And this was a fantastic way to then connect scales and to think about where that water was going in the landscape, which of course, in a heterogeneous glacial environment is highly variable. So he built his own UAV, built a multispectral mapping device, and was able to acquire some imagery in multispectral into the thermal at quite high resolution to look at what these changes look like. And so his variable of choice became the integrator, which is the soil moisture. And so to get at ground validation, he had to install instrumentation. And so this, of course, involved even more field work and more help from other students and local collaborators. And here you can see him installing calibration points and validating those and zeroing them in with differential GPS, and then able to cover the area with his drone. Now, of course, this was done in 3 different case studies. This is just one to show you. He was able to resolve at 50 centimeter resolution, some great maps, and using a modified temperature vegetation dryness index, was able to come up with some good estimates of volume content of water. Now, this may or may not play given our lack of resolution, but you can get a feel for just some of the coverage he was able to obtain. Let's just skip that. I think that's probably going to slow us down even more, given our limited bandwidth. So if we look at the data that was published in his article that's now available here, I'll give you the full reference at the bottom of the page. I guess I've hung things up. Okay, here we go. Was able to show some really interesting features. So this high resolution mapping was not only able to quantify to a first order the volume storage of some of these wetland features, but was able to also show human disturbance. And you can sort of see this in the thermal imagery, identifying not only spring inputs of emergent groundwater that was recently fed by glacier melt, but also soil compaction due to grazing through the temperature changes in the landscape, things that we would not have been able to see with our regular, it's far too small scale, high grained to pick up with our satellite imagery and not able to see on the ground. So the aerial view was important. Now I want to make a point that drones are great and high tech is great, but when we want to access data in high exposed, difficult access areas, it's often the case that low technology works best. And so what I appreciated about Ollie's dissertation was his integration of kite technology. And he was able to contribute to a very important map of a full 4 kilometer valley width, valley length that was showing some of this groundwater and streamwater interaction that he was able to map with a kite. He did it with a 1 flight because of the consistent valley winds and a clear day. And you can see that when the conditions are right, these can be very efficient. And I heard that use and attribute of UAVs already, but let's apply it to low tech as well, because when you go to these high environments, it's quite a lot of expense and you want to have redundancy, but you also want to be able to get the job done. So challenging environments are exciting, they're appealing, they get students excited about geography, and when they're tied in context to valid questions, they can really be transformative. But of course, we have to be realistic. Getting GPS control can be difficult. There can be challenging safety considerations. But ultimately, when you have the right ingredients of characteristics in students, and you have the available safety network and the broad collaborative network of local invested collaborators, a lot can happen. And this is what we've been able to leverage and come to terms with. Not only did Ollie do a great job with his soil moisture mapping, but he was then able to look at debris covered glaciers and some of the dynamics by, of course, using repeat flights, which we know can just be really, again, a spectacular way to look at detailed resolution of velocity vectors and other things. So here's a paper that is in the cryosphere that can also be accessed. And Dr. Drone, I just wanted to put that up there because as an educator, he was my first PhD student fully integrating this technology into his dissertation. And you can go to his website now. He's in New Zealand as a postdoc. He's now a father of two, and things are going well. But let me also disabuse any notion that this happens really quickly. This was a long, steady path of multiple trips to the field, multiple prototypes, and I don't trust anybody who doesn't tell me they've crashed multiple times. So, you know, it's a matter of experimenting, getting up, dusting off, and trying again. So these are just some of the prototypes, many of which were tried before the final products were delivered. So I was going to subtitle this talk, Multiple Crashes. All right, I want to shift gears to the second case study area and also to a new dimension of student integration that my innovative PhD student candidate, Forrest, as I mentioned before, instigated, called the OSU Mountain Drone Team. And what he was able to do is get a bunch of students from not only geography, but engineering and other disciplines excited about these challenges of flying a drone over Peru's highest peak. So they had an aspirational goal that you can see in their icon here, their little logo, of flying the Ranger, as they called it, over the Huascarán summit. Now, I will tell you right away that they didn't fly it all the way over the summit, but that aspiration allowed this team to make lots of interesting collaborative networks and technological developments, including pending patents and recustomizing off-the-shelf instruments. And the way that they really got trained in data acquisition and science was through a long-term investment in another field site that we've developed over the years at the Great Basin National Park in Nevada. And so this is where we have the one mapped glacier that's remaining in Nevada. If you look at the latest glacial inventories, which is really just a glacierette at the high head walls of this rock glacier. And there's the 13,000 foot peak called Wheeler. And this is a northeast aspect cirque where this persists in a very dry, internally draining endoheric basin. Well, this is a place where water is a vital and limited resource. And so what we've been doing for the last 12 years is taking small groups of students out to learn how to do physical geography in the field, doing actual research. And because this is a national park, there was a strict limit on access to drones. They had a ban, an outright ban, because it can interrupt with tourists. It can be dangerous. And so until a couple of years ago, they had a ban. So what did we do? Well, we got permission through a long-term relationship with the science team at the park to survey using other means. And so we started with kites, don't work in a cirque. We went into this aerial observation system with balloons and built our own customized stabilizing unit to get multiple photos. We'd fill the balloons with helium in the parking lot and cover them with a tarp and walk them through the trails, the kilometers access point to the glacier, and then got our ground control established with, again, differential GPS. And again, I would add that these are challenging contexts, and in a steep, high-walled cirque, there's a lot of issues in getting good signals. So that presents continuing challenges. And this is then where the Mountain Drone Team, when they finally were able to get permission, when the ban was lifted, they did the homework, which was involving a lot of paperwork, of course, to get permissions, and then licensing to get able to fly, and then getting the whole protocol worked out, including the innovative surface mapping through automation of staying at a constant height above the surface, all programmed into their GPS, and to work out their approach, which again, we use a structure for motion algorithm. We use AgiSoft. We run it using supercomputing cluster at Ohio State to get very dense point clouds. And I won't dwell too much on these technical details other than to show you some of these results done with the photos from the balloons and then integrating the drone. Now you notice we don't get full coverage because balloons don't necessarily go exactly where you want them. And furthermore, there's seasonal snowpack that can sometimes obscure the view. But again, with persistent repeat visitations, we were learning with each trip. We had new cadres of students come up with theses and present them. And this is part of the whole package of my goal as an educator. And so here we have John Morgan Manos earning the Henry Brecker Gary Mackenzie Award to take his poster to the National Association of American Geographer meeting and present it. And there's Henry Brecker himself, a polar explorer who's still with the Bird Polar and Climate Research Center. And showing some of these results, it was fascinating to learn how the glacier mass is actually evolving. Now, this is a research education enterprise, and we've learned a lot along the way. And so it's really the context, again, that's allowed us to conduct the science, do the research, and also provide this amazing hands-on learning experience. There you can see staff member Jim DeGrand, who's the Assistant State Climatologist of Ohio, and my colleague in the Geography Department, assisting with the base control. And I would remind us that no matter how well you establish protocols, you can still make mistakes. And these mistake indices go up the more you involve students. But the more you do that, the more they learn. And I mentioned that only because we forgot to turn on the base station once. And we lost a lot of good data to do our differential corrections. So this was then the drone team's output from mapping in 2018 and again in 2019. And this is ongoing work that Forrest is doing, really tremendously refining our perspective of what's going on in this really amazing geomorphic feature of a rock glacier. How old is that ice? We don't really know. What are the dynamics of these different geomorphic lobes that you can see expressed here? How is the mass moving? Where's the ice core? And what is this net loss contributing to the downstream ecosystem of this desert environment? Forrest is incorporating lots of different satellite images, satellite technology, and algorithms to look at differential motion. And this is to be published soon, but I'll stop there on the science end and just sort of pause with a little consideration of where we are with this and how this can go forward. I leave a couple photos on the screen here. On the far right, you see a very tragic scene in Peru. In 1970, there was an earthquake off the coast. This is a seismically active region of convergence that set off a huge rock fall that then also collapsed on a glacier and made a really rapidly flowing debris flow that went down this relief feature that you can see here, which is about 4 vertical kilometers over the span of 10. This debris got airlifted over a 300-meter hill and completely buried a city of Yungay, where an estimated 15,000 people are buried in that force field that you see there. This is the other side of what's going on as we loosen up the cryosphere. And I know this is a touchy, sensitive reality for those of you in India who have recently seen other flood disasters related to changes in a high alpine environment. So I just want to make the point that there's a time-sensitive and urgent need to survey these rapidly disappearing mountain glaciers. They're water resources, but they're also mountain hazards. UAVs provide a unique opportunity to empower engineering science synergy that can acquire this critical data. I think we're at a really important threshold to consider where and how we share those data. But I just want to also say that it takes a lot of time. It takes context, it takes good science questions, but it takes good people and investment in people. So I really want us to really think critically about democratizing the access to that data, because a very special interest can very quickly take over. Locals remain the experts. Local partners are essential. And I would just really emphasize that I think India has tremendous potential here. You have access to the world's highest mountain range, the third pole. You have incredibly bright engineering-minded students and faculty and staff. You have the need and you have the opportunity. And I think this presents a great opportunity. And I would hope that this synergy that we've developed over the years can continue, and we'd be happy to support this in whatever way possible. So please keep in touch. And I apologize for the technical inconveniences, but again, I congratulate you on this very long day. And if you're still listening and not asleep or starving, congratulations. I'll stop there.
Thank you so much, Brian. I mean, it's really, I'm very pleased to hear anything from you, you know that. And thanks for your recommendation, very insightful talk. And yes, of course, we would like to be in touch with you because we want to progress in this direction. Earlier today, we had a talk by Dr. Raj Ramsankaran from IIT Mumbai, and he has started a program flying drones in the Himalayas, and he had a new paper, and then he has given some recommendations in terms of accuracies and where to fly, where to have a base camp, for instance, these sort of issues. And so he has given a very interesting talk. But I want to ask, what are the two most important recommendations you want to give to academic institutions in India who are starting drone research, like IIT Roorkee?
Yeah, well, I would say again that this is a long-term investment. So you need to think about this carefully and patiently, but also think about placing the right characteristics of good science questions with thoughtful, integrated teams that learn from the outset that nobody can do this alone, and that technology is really exciting. And I think we can get really distracted and almost make a tool that we then look for a job. But it's really important that you take the time to set up the network of remembering that this is an educational initiative. This is very valuable information, and integrating from the outset local collaboration on the ground, because you'll need it for access, but you need it for relevance. Okay, and you need it for impact. So those are the kind of things I would recommend: long-term investment, local initiated collaboration, and integrated teams that are cross-disciplinary. I like the fact that there's great potential for big data analysis, but keeping those open flows and sharing protocols and lessons learned along the way really can be helpful.
One short question. I mean,
sure.
Yeah, that most of the Himalayan glaciers are very, very small. And
yes,
if we learn from European Alps, these glaciers are going to vanish by 2050, 2060. Do you think that it makes sense that we observe one of these glaciers, because it's easy to do that, instead of long valley glaciers where you don't know what's going to happen after 2 kilometers upstream?
I would agree. I would tell you that this has been an ongoing discussion in glacial studies for a very long time. What is the best representative glacier to invest to study in? Because logistically, it's very impossible to do this for everything, and you need to have good ground validation. So if you can get accessible sites that are representative, those are really valuable. And if you can maintain a presence there with repeat visitations over time, the value enhances incredibly. Install good instrumentation, good control, go and find those areas. And yes, I totally agree. I think the other thing that you can look at for climate control is these small glacier cirques that are very responsive. Because in long valley tongues, you have a lot of glacial dynamics that are built into this that are not immediately couplable to the climate. So depending on your question, I think it's important to remember that always, that those smaller glaciers can be very informative, approachable, and can be a nice consideration for study suite.
Yeah, I think it's very important because they are somehow ignored by satellite remote sensing based studies. And but they are very important because if they vanish, I mean, they are going to change the landscape. So yeah, thanks again, Brian. It is really important to you. And I would ask my students to be in touch with you. And yeah, if we have any further questions, we'll stay in touch with you. Thanks, Brian.
Great. Good luck.
Take care. Srasti?
Yes. Thank you, sir. Our next speaker is Dr. Vinod Kumar Samanthula. He is the founder and CEO at the Sense Acre Labs. Mr. Vinod is a mechanical engineer and alumnus of IIT Madras and IIM Bangalore. Dr. Vinod is a highly regarded leader with demonstrated experience in managing businesses, helping global organizations in establishing and expanding their business operations in India. His areas of expertise include market entry, globalization, business development, strategy, operating models, financing, HR and organizational transformation, and creating leaders. His specialization and sector experience ranges from IT, water, monorail, satellite communications, agriculture, healthcare, to energy and infrastructure. He is also an expert in mapping technology to business integration. He had the privilege of working as a partner in PSLV, GSLV satellite missions, and BrahMos, Akash, and Prithvi missile programs. The title of his talk will be Visual Intelligence with Drones for Agri and Environment.
Thank you very much. It's a real privilege, and I think I'm the last batsman in the seminar.
Yes, sir.
Okay, so I'll try to keep it short and simple because it's been a privilege to hear all the speakers in the panel. It is very enhancing. The only difference I bring to the table is whatever research that is happening in our country today, we are trying to do it in a commercial model. Okay, we are a commercial organization, so if you look at our logo itself, that demonstrates that we are very concerned about environment, our Vedic philosophies of our culture and our heritage of the great country we live in. And with that in mind, putting a lot of environmental concerns and agroecological principles to get back to normalcy, okay, with whatever that has happened the last 30, 35 years in terms of industrialization and corporate growth. Okay, we have made some mistakes that can be recalled. And to just put it to perspective, some of the great utilities of drones in agriculture and other I would say domains in particular, and how the technology is transforming it with commercial value. So all the presentation titles and the videos, 30-second videos will be there, which I will stream, and all of them are practical case studies done by us, by our team across the country and the world. Okay. So what we offer, as I said, is a scalable view of integration between very high-tech drones, right from the DJI's Phantoms to the very high payload sensors and industrial grade drones. We have been in this space for 6 years now, and we have imported all kinds of drones into the country, all kinds of sensors into the country, and have demonstrated enough applied commercial models which are beneficial for our clients across different verticals. Okay, and I'm privileged, actually. Dr. Rabi Sahu, we have been working for a long time, and these are the domains we work in: agriculture, trade role, urban, okay, rural India, power supply, both renewable and non-conventional energy, mining, banking, irrigation, and dams monitoring. We have enough case studies in all these sectors, and all with drones and different sensor integrations. Specific to agriculture, we have been mastering this art of using the RGP to the multispectral to the more relevant. I will just demonstrate one of the new inventions of an Israeli-India collaboration, which we are bringing to the table as a 12-band sensor, 10-band, 12-band, and 24-band sensor, just below the hyperspectral and above the multispectral. The current, which are the 5 or the 10-band sensors we have demonstrated by the mega sensors of the world. Okay, so our intent is whatever we have been doing, we want to predict color on color. Okay, very precise, so that whatever satellite has some weaknesses of demonstration, we are trying to address that with drones. And with that, we targeted test and weed detection as a prime importance, because this will actually put us back into the goodness of putting the water tables back into a better system, our soil utility in a better system, our nature into a better system. All the ecological balances will come back, because as we speak, you will see the reduction in the agrochemical intake in the cultivation process itself is a game changer for our country, for our soil, for our ecology. Okay, so this is a typical indication of the first order analysis. Everybody understands, as we go deeper of inside of a very precise agricultural monitoring, you need very low and very high-end, very low flights and very high-end imagery with high resolution. So satellites has their limitations. There are satellites which can give you images of very high quality, but again, they are expensive. Okay, so in that regard, what we have observed is, there are great sensors available in the market today, which are doing some wonderful job with the 40 megapixel and above, which are giving you very high resolution data. Okay, this is a typical start. Okay, I will put some videos into perspective. This is a typical start of how drones started off as an agriculture. In such large areas, if our farmers are saying that, we are doing crop monitoring across this area, I think, there is still a question to that particular, caliber of moving around such a large extent. This is 10 square kilometer area, where we have actually, done detection of striga weed, okay, to do the mapping of the striga weed, and then subsequently identified that there's no striga weed, but there are more other weeds on this soil body, okay, and that was a sesame crop, in a summer crop in the Telangana area. These are the typical sensors, everybody knows about it, and they have their strengths and weaknesses. Because of the lack of more precision or more accuracy in terms of megapixels and all that, we still have limitations. Whatever we have, we are using, but there is still a lot of opportunity in optics, I would say, to integrate these two drones and get better data for analytics and precision agriculture. These are some of the annotations of the previous slide. Okay, whatever we have done. This is how we started, and typically, you get a lot of indicators of after the processing the optomosaics and stuff like that. You get the stress of the crop area, water bodies, and all that. And then this is the change we have brought into the table, using the same UAVs flying across large areas and getting into very specifics of crop health monitoring. That to detection of the stress, the pest, and the weed. Okay, so we have calibrated that into one single platform where now once you detect the entire plot, you find some observations, and then you can get into very specifics and then start training that into an algorithm based detection and then annotate it across the crop area. So we have been very successful in doing this model, and these are a couple of observations on the multispectral imagery, where you fly very low and then you get this kind of observations. And then, as I said, green on green, for example, grasshopper, you can't go with a naked eye, say from even 100 meters distance or even 1 meter distance and say that the grasshopper is on the crop. Okay, but on an NIR, okay, maybe you get a detection immediately. And the same, once it is trained into an algorithm, you can actually annotate that and do a complete modeling of across the crop area of the detection. The advantage of doing such kind of predictions is when you are actually doing spraying for pesticides, okay, because in most of the agricultural experts understand that today in India our utilization of agrochemicals, whether it is pesticides, fungicides, herbicides, insecticides, all kinds of agrochemicals. At least 5 to 6 times crop season, the spraying is being done. Even at the flowering stage, okay, they are doing spraying, and that is a disadvantage. And this is a direct reflection of our healthcare industry. The way the healthcare industry is booming, it's a $70 billion industry, which means that people are getting sick. So we have to understand the biggest reason for becoming sick is food, crop, and water. Okay, so if we can actually determine these and bring back our environment and food processes into a more legitimate way of reducing and making it semi-organic and futurely organic, I think we have a great space. Deeper the algorithms, we are getting into millimeter data, okay, per pixel, and then trying to give more predictable stress analysis on each crop, and this can be across 1 acre, 10 acre, 1,000 hectares. Okay, the largest we have done is 1,000 hectares crop modeling. And these are a couple of indices, you can work on having 10 bands and 12 band sensors with a lot of reflectance values and wavelength values. You can do modeling, all typical NDVIs are no more an acceptable limit, because there's a lot that is being expected from image analytics nowadays. So you get into the details of NDRE, okay, the leaf area index, WARI, and all that, getting into more details of whether we can go deeper into the soil and get some moisture data. We are still working on it. I cannot today confirm that we can do prediction of soil moisture, but yes, there are some samples which we are collecting, and probably maybe in 1 month or 2 months time we'll be in a position to tell that at least some predictions on soil moisture can be done through drone imagery. Okay, this is one sensor which is patented in the US and which has come very recently, and we are the India collaboration partners. And this is a 4-band, 8-band, and a 12-band multispectral sensor, and with very high resolution. Okay, typically the competition you see is 2 megapixel per band, and here per band we are giving around 12 megapixel. Okay, so that's the kind of clarity of capture you get, and the detailing you get into when you process and start looking at predictions. Okay, is a game changer. This is a typical view of MicaSense with the 5-band, okay, which we have done for lake monitoring, and you can see the clear observance of algae formation, okay, on the lake body. Okay, this is one we are doing for, again, environmental protection in lakes in Telangana, and that's going good. As I said, we are training our algorithms and detecting pests, okay, and trying to build some spectral imagery data, which will be helpful to all of farmers. Maybe over a period of time we may give it free, but currently we are collecting data, and today we are in a situation where we can say we have cotton, maize, and rice and chili. Okay, these 4 crops, we are comfortable, and we are collecting more data from straight from sowing date to the yield date. Okay, so that more data, more observance, and more predictable algorithms can be built, and can be modeled with a lot of better prediction. Today we are around 86% accuracy, but we want to touch the 98s and the 100s to be more predictive. Okay, these are some of the, as I said, spectral imagery bands we want to build for a period of time to tackle the stress of each plant. And when I say stress, I have to go at leaf level. So we are trying to build that kind of models. And again, yes, you have too many about them. But currently we are trying to focus on pink bollworm and fall armyworm, which are the biggest disasters of our country in agriculture. So we are trying to predict them. And then on the irregularities of the crop health, okay, whether it is NPK problem or anything. So as I said, the sensor is so beautiful that the lower you fly, the better you get millimeter per pixel data, and with highest effectiveness of focal length, and which currently in true precision agricultural terminology, I think there is nobody in the country who can give such kind of very high resolution data at a very economical value, because end of the day, India looks at a price for everything that is offered as a service. This is a typical workflow. Everybody who uses drones know it. We scan, okay, and detect, and then analyze, and send high resolution cameras. And this is again integrated to mobile applications. So when you're doing your ground truthing, you can actually straight away go to the GPS coordinates and start looking at whether whatever we have predicted is correct or not. So we have taken some great advice from different scientists of ICAR, ICRISAT, PGTSU, ANGRU, and all these kind of agriculture universities to help us in doing these ground truthing exercises, so that the credibility is on a very higher side. But as we speak, we are doing a lot of other researchers outside of India, and they are doing extremely well. Okay, they're very progressive. This is the typical, this is the way how a survey would be determined, that it is whether it is efficient or not. Most of you will agree. It is a resolution of the acquired imagery captured at what consistency and at what expandable limits. Horizontal field of view, degree of overlapping required for making the optomosaic fit. Because in some of the water bodies, when we capture multispectral imagery, you don't get water body. You get the base of the entire ortho. Effective ground truthing methods to ensure that whatever we have captured is clear and precise. Okay. As we speak, we have mastered this art of flying across Rabi crops and Kharif crops and summer crops. And we have determined the 90-day crop and the 120-day crop cycles, how the drone has to be utilized in agriculture. 3 to 4 times for crop health monitoring, and maybe 3 to 4 times in spraying. So we have made this ecosystem built, and today we are waiting for approvals from the ICAR organizations for SOPs, because at the end of the day, when a commercial organization moves forward ahead of time, also we'll have to wait for approvals. So that's the situation we are in. Otherwise, we have done enough experiment. I wouldn't say experiment, but commercial deployments of such scale. Okay, where we have done 1 lakh hectares of crop health monitoring and around 50,000 acres of spraying. Okay, in different regions of South India. Okay, these are typical indicators you get, indices you get, the typical orthomosaic, digital surface model, then crop area identification. Because every speaker in this body knows that India has small farm holdings, maybe half acre to 5 acres as slots, and 60 to 70% of land holding is in the same category. Again, on top of this, in this half acre to 5 acres, you have multiple crops in the same land area. So that's the variance you have to detect. So you should be capable of, or your sensors and your processes should be capable of identifying the land area, the crop, and the variance in the crop, and then the other predictive indicators of plant health, crop health, and the yield predictions. So we have the Greenleaf Index, Variable Atmosphere Index, which gives you predictable normalized in GRD. As everybody knows, WARI gives you a little bit of indicators on the moisture and the leaf area index, canopy cover, restricting to biomass and all that stuff. So again, once that is done, we want to integrate. Yet we are not ready, but we are doing 2 parallel things. We are doing spraying. Once the crop health is done, as per the crop season, we do spraying. Yeah, typical. No, we have imported. Again, since most of the stuff is not available in India, it's a more of assembly of make in India. We have all these kind of drones, from the typical 10 liter, 15 liter, 20 liter, battery-based hybrid models, fog spraying machines, all kinds of possible combinations for doing large-scale deployments. We have done that for India, for Indian farmers. The last 2 years, we have done enough silent revolution in this industry. And then currently we are working with Dr. Abdul Kalam Applied UAV Research Labs in Chennai, MIT, for hybrid modeling. Okay, this is one of the hybrid model you see, which was recently used in the locust problem. Okay, when India was targeting locust problem, we deployed these machines in Rajasthan and other border areas, and they were very successful in doing some, I would say, quarantine of these measures. And the right one to the right is the longest endurance drone in hybrid model. It's from Spain. Okay, and this is also doing extremely well. As we speak, yesterday they broke their own world record from 8 hours to 10 hours endurance. So these are the kind of systems we want to. We were already in collaboration with them, but we want to bring them to India. Okay, for the good of the country. Okay, and mostly for the farmers. This is a hybrid model. It runs both on petrol and battery. This covers very large areas. Okay, per day, you can cover up to 60 to 70 acres per day. And this is since compliance is becoming a big issue in our country, and no imported drone is allowed to do whatever it is allowed to be is eligible for. We are moving to make in India drones, and currently we are working with 2 companies, one in Hyderabad and one in Bangalore. We have procured their platforms and doing good stuff. Model B is an incubator of IIT Hyderabad. We bought it and it's doing well. And we have procured another one from CAS, Bangalore, which is also doing good in survey. Okay, and this Model B is specific to multispectral integration. The challenge in India we face today is you can't actually swap the sensor if you have a model which is approved by DGCA conditionally. Okay, so that is a challenge all the Indian entrepreneurs are facing for commercial deployment. Okay, so that and you are banned from importing. Okay, and on the other side of technology improvements, the traditional GCPs and the DGPS systems are moving ahead. We have integrated the RTKs and the PPKs for both the drones we have in our fleet today within Make in India. We have integration of RTK and PPK. Okay, so that a lot of homework on the ground for doing all these DGPS, GCPs and all that conditions apply. You can minimize by 50 to 60% of the work. So you can better target on the RTKs and the PPKs and get more accurate GPS data. Okay, this is one tip here. Drone as a data, because we want to deploy drones not as a sale, because we want to become a system integrator. And our thought process is drone as a service gives a lot of opportunity, because still the ecosystem is evolving in terms of manufacturing. And as we progress, maybe 5 years from today, we can say we have the DJIs and the MMCs of the world in India and the Senflights of the world in India. But today we are not ready. Okay, so but in terms of deployment, there is tremendous opportunity in the country. And again, as a lot of speakers in the agricultural area are talking about abiotic stress and biotic stress. We are also working on that. And recently, because of COVID, we had imported one machine from Netherlands, Aquox, and we have started working on the electrochemically activated water for disinfection, which is used very highly in the healthcare industry and hospitals for injury care. Okay, so we are trying to use the same kind of research or applied research interventions both in Netherlands, Europe, and US to bring them into improving the shelf life of our crop. And then probably, typically in any mandi, you have tons of vegetables being thrown away, whether it is tomatoes or any other cauliflower, leafy vegetables, thrown at the end of the day into as municipal solid waste. So what we are trying to achieve is probably improve the shelf life by 24 to 48 hours and ensure that this crop is bought by us and given to the poor and the needy through the ISKCON organizations, which are the largest community regions. So we are also working on that model, okay, to get us there. And as we speak, once drones get into effective acceptance, today itself, we can confirm by using drones, you can reduce 30% of your inputs cost in the agrochemicals, whether it is pesticide, herbicide, weedicide, fungicide, or fertilizer. So you can reduce that. On top of it, you are saving water. On top of it, you are saving environment, both soil and water contamination. Okay, and specifically, most of the carcinogenic material of these agrochemicals are affecting our health, and especially today, farmers are unhealthy because of these agrochemicals, and that's the reason why we would always want farmers to be educated to reduce their agrochemical consumption and do better crop monitoring and better yield prediction in whichever way possible. If you see this slide, this is more I would say socio-economic, but everybody in the system who is in agriculture, okay, from the banks to insurance companies to agents to micro irrigation companies, power companies, you take everybody in the system from retails to the last mandi, everybody makes money except farmers. Farmer is still asking for money. So there's something, grassroots level, there is something to really think about, transforming this particular system to go back to farmer and make him more profitable. Okay, that's about agriculture. Okay, since agriculture is not giving us too much money, honestly, and the opportunity for scale is still on the compliance side questionable. So we moved into other industries. This is on the railways and roads. As I said, we have all the fleet of sensors with us, and it's great to see. On roads, you can right from planning stage itself, you can do road monitoring. You can do all the volumetric analysis of truck volume, field volume. If it has 2 lane, 4 lane, you can start doing all the interventions possible, and also come up with your BOM. Okay, as we process this imagery, once it is constructed, you can do the O&M management. Okay, and also the medians which are in the middle. You can also look at them how good they are, whether they are being managed properly, whether the toll roads are being managed properly. So these are some of the interventions, and HAI has already started using drones, and this is going big time with Mr. Gadkari being in the leadership. Okay, and on the urban railroad, all the high-rise buildings constructions monitoring, we are doing it in Hyderabad. And the majority of the cases, what happens is, if you have a building information modeling integrated to this particular drone systems, the outcomes are fantastic. Okay, all the leakages, in terms of delays in construction activity can be actually, foresighted. Okay, and for banks and insurances, what we have done is all the project financing for such large infrastructure projects can be monitored visually, and there is enough intelligence for them on disbursement value on the actual construction site, planned, constructed versus the deviance. Okay, if there is anything, they can reduce or stop the payment for the second stage of deployment. Okay, so these are large high-rise buildings monitoring. Since I'm last, I'll quickly wrap it up. But this is again ICARE. A lot of people know when they're in the construction phase. We were doing deployment of all the renewable and non-renewable energy monitoring. This is more a video, but otherwise, what we are trying to do is detection of any gas leakages from the portfolio of construction above the floors. This is again small hold. There is a typical rural housing programs, 1 bedroom, 2 bedroom, large scale activity which comes under for the poor. These are activities which are built for Telangana and Andhra. We are doing a lot of activity in construction monitoring. I mean, this gives you, this is another typical layout of integrating a complete Gram Panchayat. You look at the left legend, those are all the input costs, okay, that go into from different departments, whether it is irrigation, rural development, panchayat raj, urban development, municipality, whichever it is concerned, but the footprint of the delivery is through this only. So we have integrated the complete landscape through GIS and drone mapping, so that every investment penny which goes from I would say the pole, the electric pole to the water body to the construction deviation to temples to every building, every structure, livable, non-livable, I would say, has been mapped. And these are the indicators, and this can be given with a color determination, so that whichever you want to detect and protect, you can always check it on the fly. This is a 3D modeling of a smart city. Okay, where all the creatures, at centimeter level data, whatever is the progress management, you can determine the progress based on the area-based development. And these are on the 3D models. You can see all 360-degree view of any construction activity. Okay, on the power, okay, we have done extensive work with thermal on insulator management, power line transmission monitoring, okay, inspection of power lines, okay, for the big giants in our country. And this is typical one example of. So this is again on the solar side. Okay, you can do complete, cell-to-cell mapping of solar plants from construction to O&M service, and give them efficiently what is the loss percentage. Okay, when the cells are not being charged properly. Okay. So this is a typical layout on the thermal mapping, and you get a lot of indicators through this of what is the quantum of power supply that's being reduced because of the other one. And this is on windmills again. Okay. So here we can do turbine monitoring, wind vane management, okay, power management, and all this kind of stuff. Okay, for basically for the O&M activity. In mining, again, all the above surface mines. We can do volumetric analysis and doing a differential of captive versus the excavated models. And this is again one of the cement limestone quarry, how it is being excavated. And then, as I said, progress monitoring, we can give dashboards on the progress monitoring for any construction activity for large indicators. Anything about 250 crores today will have a third-party visual evidence through a lending assessment engineers, and we are one of the part to that particular visual intelligence program with SBI. On the disaster management, this is the best evidence for anybody. Recently, Hyderabad was flooded, and we have done the drone survey and actually got into details of what are all the, I would say, to the left and the right of the lake encroachment. Okay, how the lakes have been encroached and why the disaster has become so big, which has got into the city. So these indicators have been effectively deployed, and state is taking extreme actions to ensure that such calamities don't be addressed. I would say they will be definitely addressed in future, but currently the work is in progress in determining which are all the encroached bodies that needs to be demolished. That data is already in place with all these observatory evidence, both in terms of video and imagery. So again, irrigation and dams. This is the largest dam in the world, Kaleshwaram. 1 lakh crores, 136 packages across hundreds of square kilometers across Telangana. We have done the progress monitoring for the last 4 years, and effectively KPMG audited this, and then it is commissioned. Okay, a typical how the stamping is done for typical barrage. You can get all the details of excavation, built up structures, okay, progress monitor. And this is a huge, I would say, reservoir built closer to Telangana outskirts. This is the panoramic view of the entire, this thing. This is the kind of observatory evidence you get. This is Polavaram Dam in Andhra. Again, we did the complete review, and then presented to the Honorable Chief Minister. So this is also all the new construction management, where it is, where it started, how is it doing. Again, in environment and forests, yeah, we have done forest monitoring also, and this is a typical LiDAR, okay, integration for a particular smart city in Kerala. Again, for a lot of water modeling, to see that they also have the problem of encroachment in all the current lakes, okay, in Kerala. So they are also coming up with a lot of indicators, with this LiDAR processing, and then getting more detailed interventions. This is more on the application side of video analytics on drones for capturing imagery for theft or for any animal detection, car detection, and all that. We have done that. And then on a real-time video analytics on drone, we can give you the number of houses, number of cars, number of people walking through, all that kind of indicators. These algorithms have already been built, tested, and deployed. This is being used by Johannesburg Metro. We are doing this project for Johannesburg Metropolis in Africa. Okay, so this is a 3-year contract, which is doing good and showing good results for us. Okay, and they also have encroachments across, and we are determining on a periodic basis, 15-day basis. All the open areas will be flown with drones, and if there is any encroachment, that will be modeled and highlighted, which will be taken as an action by the concerned authorities. This is the typical flow chart, I would say, the methodology of how we do right from mission planning to giving you outcomes of whatever the customer wants. Okay, so being a commercial organization, we understand drone as Dr. Rabin and others were saying, it is a very process intensive. You need very high performance machines to do a lot of work. So we are targeting, if at all we are targeting big numbers, we are targeting petabytes of data of storage and processing powers. So in quantums of 1,000 acres or hectares, as I said, in units of 1,000 hectares, we have all the mission ready, okay, and we can do it parallelly. Again, these are technology integrations. India has a long way to go. Okay, I think if we have to do everything as Make in India, these are the typical components which can be industry specific, and then each unit can become an industry by itself if India takes a big leap in drone acceptance. One classic example I can give you as an industry 4.0 job creator. India has 250,000 panchayats in our country, and if each panchayat has one drone as a minimal, with 3 jobs creation, we are creating 750,000 jobs in our country around agriculture in rural India. Okay, this is the opportunity that India has, which probably the other foreign companies can also not take it as a serious opportunity in terms of business, and then come into India for Make in India and integrate with everybody and anybody. These are some of the use cases we have done. We have done NABARD, very large project in West Bengal for body monitoring, and we have given some amazing outcomes of the leakages. Okay, and then what has to be protected. Again, this is for government of Karnataka. Typical.
Excuse me, sir.
Yeah.
Sir, I'm sorry to interrupt you, but actually, sir, we extended the time of the meeting till 8
done.
o'clock.
I'm done.
Yeah. Yes. Okay, sir.
Thank you very much.
Yeah, okay. So very, very impressive work, Dr. Vinod Kumar. I just have a very quick, I was thinking like, is there something that you don't do? So do you envision a future scenario where farmers can, use this technology where the data acquisition and processing can be done in the villages, and they have this analysis ready data for their, for their businesses? Do you envision something like that?
Yes. See, there is a program called Custom Hiring Centers or FPOs, which the Government of India is actually pushing hard. FPOs is a combination of say 100 to 1,000 farmers coming together as one unit. So these people can have one crop health monitoring drone and one spraying drone, 1 or 2 spraying drones, because spraying drones are little low in coverage area. So you can have a mix and match of one crop health monitoring drone and 2 spraying drones for each panchayat. So this will create jobs, and the acceptability of this technology for immediate interventions, okay, will be like any other tractor. Okay, so that can become the serious opportunity creator, because I've seen farmers are very much interested, but what do they need immediately is spraying more than crop health monitoring. So if you look at, if you ask me as a business, there is huge potential for spraying as an activity, okay, which they're willing to pay, but not for crop health monitoring. So they don't bother about what pest is coming in. They're saying, can you actually come and spray it in 15 minutes per acre?
Okay, thank you very much.
Yeah, sure. Thank you very much for this opportunity, Dr. Rabin. And thanks to Dr. Chandra for recommending me to this event. Thank you very much.
Thank you, sir, for enlightening us with your knowledge. Yeah. We feel really grateful having the opportunity to hear from all the intellectuals all together on this platform. I also thank our online audience for your participation. With this, I close the session, and we'll meet again tomorrow at 9 a.m. Thank you.
Thank you.
Thank you.
Thank you, sir. Bye-bye.
Thanks.